Have you ever wondered why the unknown feels so close? Almost familiar? Tonight on Calm Science Sleep, we'll drift through the quiet edge where science meets mystery, from the mind's illusions to the calm logic behind the paranormal. Softly paced, gentle, and clear. A journey made to slow your thoughts, not to stir them. Stay with us until the end, and let curiosity carry you into sleep. When we speak about paranormal phenomena, we usually mean experiences that seem to sit just outside the borders of what science can explain. A strange light in the corner of a room, a whisper with no clear source, a sense that someone is standing behind you when you are alone. These are stories as old as humanity itself. They fill every culture and every period of history. Yet today, neuroscience and psychology allow us to look at them from a new and gentle angle, one that neither mocks belief nor glorifies mystery, but simply asks what the human brain might be doing when the world feels more than natural. Across centuries, people have tried to define the boundary between the ordinary and the extraordinary. The word paranormal itself only appeared in the early 20th century, when researchers first began to collect reports of telepathy, apparitions, or objects that moved without visible cause. But the fascination is far older. Ancient Greeks wrote about divine messages carried through dreams. Medieval scholars debated whether visions were holy or deceptive. And modern spiritual movements turned personal emotion into evidence of another realm. Through every era, the same question returned in a different form. Is there something beyond us? Or are we simply seeing the edges of our own minds? Science does not begin with disbelief, it begins with curiosity. When psychologists started studying perception, they discovered that the human brain is not a perfect camera recording the outside world. It is a creative system, constantly interpreting, filling gaps, and shaping raw sensory input into coherent experience. In that constant process of construction, small distortions can appear. They may last for only a moment, but they can feel utterly real. A brief shadow, an unexplained sound, or the sudden sense of being watched can arise from normal neural processes, tuned by expectation and emotion. Many so-called paranormal experiences share a simple structure. Something ambiguous occurs, and the brain searches for a pattern. The pattern it finds depends on memory, culture, and context. A flicker of movement in a dark room may become a ghost if one expects to find a ghost. The same flicker in daylight might go unnoticed. This flexible meaning-making is a hallmark of human cognition. It is what allows us to recognize faces, read language, and imagine possibilities, but it also makes us vulnerable to illusion. In quiet environments or moments of stress, the threshold for detection drops. Our sensory systems amplify uncertainty, translating noise into significance. Early investigations into spiritual phenomena, often conducted by physicists and philosophers, gradually gave way to controlled experiments. The Society for Psychical Research, founded in London in 1882, tried to test claims of telepathy and mediumship using methods that would later inspire modern psychology. The results were inconsistent, but the attempt itself revealed something valuable: how much expectation shapes observation. When subjects believed they were witnessing something extraordinary, they were more likely to misperceive coincidences as cause and effect. The brain's desire for order, combined with emotional investment, can turn random events into meaningful narratives. Cognitive scientists now describe this tendency through concepts such as pattern recognition bias and agency detection. Evolution may have favored minds that err on the side of caution-seeing intention, where none exists because missing a real threat was costlier than imagining one. In ancient forests, hearing a rustle and assuming it was a predator could save a life. That same bias, carried into modern settings, can make us sense presence in an empty house or read purpose into the random movements of light and sound. The paranormal, in this view, is not a separate realm, but a mirror held up to the architecture of perception. Cultural context deepens the experience. In societies where ancestors or spirits are part of daily life, a sudden chill in the air may confirm their nearness. In highly technological cultures, the same event might be described in terms of electromagnetic fields or quantum mysteries. The language changes, but the psychological mechanism remains constant. Ambiguity invites explanation, and the explanation reflects collective belief. Anthropologists studying such experiences emphasize that they fulfill social and emotional functions providing comfort, meaning, or moral guidance beyond any physical manifestation. Modern neuroscience adds a finer lens. Functional imaging shows that regions involved in emotion, memory, and self-representation often activate together during extraordinary experiences. The temporal and parietal lobes, which integrate sensory information and map the body in space, are particularly sensitive. Subtle disturbances there can produce the feeling that one is floating outside the body, or that another presence occupies the same space. These findings do not dismiss the experience. They describe its biological stage. The subjective reality remains powerful precisely because it is generated inside the very organ that defines reality. For us, consider the role of expectation again. Experiments using suggestion demonstrate how easily perception can be guided. When volunteers are told that a room is haunted, they report more unusual sensations, drafts, whispers, shifts in temperature than those entering the same room without context. Nothing material changes except belief. Expectation acts like a lens, brightening certain signals and dimming others. Through it, imagination and perception intertwine until they are difficult to separate. Emotion also colors perception. Anxiety heightens alertness and narrows focus. Calm expands it. In moments of fear or grief, the brain becomes tuned to detect relevance everywhere, seeking connection and control. This is why people mourning a loved one may feel a sudden presence or hear a familiar voice. The experience can bring comfort and continuity. From a neurobiological point of view, it may arise from spontaneous activation of memory circuits combined with the sensory prediction systems that maintain our internal model of the world. When expectation meets longing, the boundary between inside and outside briefly dissolves. It is easy to treat such moments as errors, but they are also windows into how consciousness maintains coherence. The same predictive processes that occasionally misfire are what allow us to navigate the world efficiently. Our brains constantly forecast what should happen next, what sound follows a closing door, what shape a familiar face should have in dim light. When the prediction fails, we notice the discrepancy as something uncanny. The strangeness is not in the world. It is in the gap between expectation and input. Throughout history, societies have cycled between skepticism and fascination. During the Enlightenment, reason became the guiding principle, yet ghost stories flourished in literature. In the age of digital technology, online communities share accounts of unexplained coincidences while using scientific vocabulary to frame them. The coexistence of rational analysis and emotional wonder may be a permanent feature of human thought. Both emerge from the same need to make sense of a complex and unpredictable universe. Understanding this does not require one to reject mystery. On the contrary, it invites a quieter form of curiosity, one that acknowledges how limited our senses are and how creative our brains can be. The paranormal, viewed gently, is less about proving or disproving external forces and more about exploring the depths of perception itself. Each story of a haunting, each report of telepathy or déjà vu becomes part of a larger narrative about consciousness, how it constructs, protects, and occasionally surprises itself. When researchers approach these experiences with empathy rather than dismissal, participants often describe feeling relieved. They learn that their perceptions are not signs of instability, but expressions of normal brain function under unusual circumstances. Such understanding bridges the divide between scientific explanation and personal meaning. It respects the authenticity of the feeling while clarifying the mechanism behind it. In this way, science can be both grounding and compassionate. One could think of the brain as an instrument, constantly tuning itself to the frequencies of reality. Most of the time, it resonates with the external world. Occasionally, it generates a tone of its own. That internal resonance may feel foreign, as if coming from elsewhere, yet it belongs to us completely. Recognizing this can turn fear into fascination and confusion into calm awareness. As we continue, the question becomes subtler. If the brain can create sensations so vivid that they mimic external reality, what exactly is real? Neuroscience suggests that perception is not a mirror, but a model, a dynamic, self-updating simulation that keeps us oriented in space and time. To understand the paranormal, we must first understand how that simulation is built, and how its seams sometimes show through. And so the path leads inward, into the quiet architecture of perception itself, the intricate system through which the brain generates the world we think we see. The human brain does not simply receive the world, it creates it. Every color, sound, and texture passes through countless filters before reaching awareness. The external world provides raw data, yet it is the brain that shapes it into meaning, blending sensation with memory until perception feels effortless. At its core, the brain is a prediction engine. It constantly anticipates what comes next, the next note in a song, the curve of a familiar face, the word that completes a sentence. When expectation and reality align, experience flows smoothly. When they differ, the error signals surprise or curiosity. Perception is thus not passive seeing, but active inference. Neuroscientists describe this process as predictive coding. The brain continuously generates hypotheses about the world and tests them against incoming sensory data. Sensory regions send information upward, while higher areas send predictions downward. Where the two disagree, a prediction error arises, prompting the brain to update its model. This cycle runs hundreds of times per second, sustaining the illusion of a stable world. Because the system strives for coherence, it fills in missing details when input is incomplete. Shadows, echoes, or partial shapes rarely confuse us. Memory and context smooth the gaps. Yet this same efficiency can mislead. Strong expectations can override the senses, making us see what we believe rather than what exists. Vision illustrates this beautifully. Light reaching the retina produces fragmentary signals. The eyes dart in small saccades, each capturing a fragment that the brain stitches into continuity. The result is a seamless world image, a mental film edited in real time. Without this constant integration, reality would appear fragmented and flickering. The same creativity shapes hearing. The ear converts vibrations into impulses, but the brain decides which belong to speech, rhythm, or noise. Sometimes it hears patterns where none exist, voices in static, or hidden melodies in random sound. This phenomenon, auditory pareidolia, reveals that hearing, like sight, depends on imagination stabilized by expectation. Even touch, seemingly direct, is interpretation. Sensors register pressure and temperature, but the sense of shape and ownership arises in cortical maps. In experiments with prosthetic limbs, synchronized sight and touch can make a person feel that a fake hand is theirs. The brain values coherence more than accuracy. It adopts any signal that fits its internal model of the body. Emotion and memory further color perception. The limbic system tags sensations as pleasant or threatening. The hippocampus links them to personal context. Under fear, vision narrows and contrast intensifies, creating a reality sharpened by emotion. The result is not false perception, but perception shaped by physiology and feeling. Modern imaging confirms that perception is distributed across the brain. Simple visual patterns activate not only the visual cortex, but also areas linked to attention and memory. Conscious experience emerges from this conversation among billions of neurons agreeing moment by moment on what the world probably is. When sensory input weakens or conflicts, that agreement wavers. In darkness, isolation, or stress, the brain's predictions fill the void more assertively. A half-seen shape may recruit facial recognition circuits. A faint sound may engage language regions. The result can feel vividly real, even without external cause. Research into hallucinations and illusions shows that both stem from predictive mechanisms. The difference lies in how strongly expectation outweighs evidence. Philosopher Anil Seth calls consciousness a controlled hallucination. The phrase reminds us that perception is the brain's best guess, anchored by sensory input. When that anchor loosens through fatigue, emotion, or altered states, the mind can project its inner model outward. Many paranormal experiences may reflect this temporary shift in balance between imagination and data. The same principle shapes our sense of self. The brain doesn't just model the world, it models the body within it. Signals from muscles and skin form a boundary of identity, defining where I end and everything else begins. When visual and bodily information misalign, as in out-of-body experiments, that boundary can slip. The self, like perception, is a dynamic construction. Across all senses, integration maintains unity. Visual, auditory, and tactile streams converge in parietal and collicular networks, merging into a single coherent scene. When these integrations falter, confusion or dissociation follows, yet the brain tirelessly restores order. This drive for coherence underlies consciousness itself. In daily life, we trust the system completely. Only in brief anomalies, déjà vu, phantom sensations, optical tricks, do we glimpse the machinery beneath awareness. These moments are not failures, but windows into how the mind continually negotiates with the world. Recognizing the brain as a generator of reality brings perspective. The extraordinary and the ordinary arise from the same predictive fabric. Art, science, and mystical visions differ not in kind, but in the weighting between expectation and perception. Understanding this balance allows us to see the paranormal not as intrusion from elsewhere, but as a variation in the way reality is built inside us. If the mind composes the world from signals and guesses, then illusions become clues, tiny experiments revealing how that composition works. And so, as our exploration continues, we turn to those gentle distortions, the illusions that expose in miniature how the vast theater of perception is staged. Every human sense is a dialogue between the world and the brain. Illusions reveal how that dialogue works. They are not flaws of perception, but demonstrations of its design. When we study illusions, we see the strategies by which the brain converts limited input into a coherent world. The fact that many illusions are universal shows how deeply they are rooted in our shared neural architecture. Visual illusions are the clearest examples. Parallel lines that appear to bend, or squares that seem different in brightness, though identical in light, exist because vision measures contrast rather than absolutes. Neurons in the visual cortex highlight edges and changes, features that matter most for survival. When this emphasis is exaggerated, the brain creates false boundaries. Illusion is the shadow cast by an adaptive system. Motion illusions arise for similar reasons. Patterns that seem to swirl or pulse result from small differences in brightness and the micromovements of our eyes. These constant saccades refresh the image. When neighboring cells adapt at different rates, the brain interprets the shifts as motion. The mechanism that once helped detect predators now animates still pictures. Color illusions stem from the brain's need for stability. We see colors relative to lighting conditions. A white object under blue light still looks white because the brain compensates for illumination. When different people estimate that lighting differently, as with the famous blue and black or white and gold dress, their corrections diverge. The disagreement was never about the dress, but about the silent assumptions inside. Perception.sound follows the same logic. The shepherd tone and endless rising pitch is built from overlapping scales that fade in and out, fooling the brain's sense of progression. The McGurk effect shows how hearing merges with sight. When a ba sound is paired with lips mouthing fa, most listeners hear fa. Vision and audition collaborate, guided by expectation rather than accuracy. Touch and body sense are equally malleable. In the rubber hand illusion, synchronized stroking of a fake and a hidden real hand convinces the brain that the artificial one belongs to the body. Ownership follows coherence, not anatomy. Phantom limb sensations in amputees arise from the same principle. Unused brain regions remain active, producing vivid but incorporeal feelings. Perception of time is another subtle illusion. Conscious awareness does not register the present instant directly. It averages events across small windows of about 1/10 of a second. This smoothing allows us to predict motion and maintain continuity. When stimuli fall outside that rhythm, we misjudge their sequence, an insight that shows consciousness lags slightly behind reality. Always composing a coherent story from fragments, the brain's efficiency relies on shortcuts, heuristics that trade precision for speed. Most of the time, they serve us well. But when cues are ambiguous, these same shortcuts create false patterns. The tendency to see faces in clouds or figures in shadows, known as pareidolia, results from specialized neural circuits for face detection firing at the slightest resemblance. The mind prefers a false alarm to a missed connection. From the 19th century onward, scientists recognized this pattern. Helmholtz described perception as unconscious inference, and later Gestalt psychologists showed that the brain organizes stimuli into wholes based on principles like closure and symmetry. We see circles where only arcs exist, or continuous lines where fragments align. Modern neuroscience confirms that illusions arise when top-down expectations outweigh sensory evidence and internal prediction. Overriding external data, illusions depend on context. Change lighting, framing, or background, and the same object appears different in size or distance. This adaptability helps us navigate changing conditions, but it also enables convincing virtual realities. The brain accepts simulation as truth whenever its internal rules of coherence are satisfied. Beyond entertainment, illusions reveal how personal perception can be. Age, mood, and experience subtly shift the balance between expectation and input. What one person hears as a faint hum, another may call a whisper. These differences remind us that each mind constructs its own version of reality, overlapping, but never identical. Studying illusions brings philosophical calm. If the senses can be deceived so easily, certainty becomes fluid. Knowledge is not absolute, but continually refined through awareness of error. Understanding how perception can fail strengthens trust in its usual success. Illusions are the harmless cost of a predictive system, designed for survival. They also provide a bridge to experiences often labeled paranormal. In dim light, under stress or isolation, the same mechanisms amplify. Shadows shift, sounds distort, and the brain, seeking meaning, fills in what it cannot confirm. Recognizing this does not dismiss the wonder such moments inspire. It explains their origin in the remarkable adaptability of human perception. Today, scientists combine psychophysics, brain imaging, and computational models to explore these processes. Virtual reality experiments test how expectation shapes presence. The more precisely we understand these interactions, the clearer it becomes that illusions are not exceptions, but examples of how consciousness builds reality. Even with all this knowledge, illusions retain quiet beauty. They expose the elegance of the system that binds neurons, senses, and meaning into a single shifting experience. Reality, viewed through them, is both discovered and invented, an active harmony between the world and the mind. And as our journey continues, the focus turns inward. If perception can conjure movement or form from minimal data, it can also create something more subtle, the unmistakable feeling that another presence is near. Understanding that sensation will guide us to the next step, the feeling of presence. Few sensations are more vivid than the feeling that someone stands just behind you. The air seems to change weight, a subtle awareness of proximity grows, and instinct prepares the body to react. Yet when you turn, there is no one there. This experience, often described as eerie but deeply convincing, is known in neuroscience as the feeling of presence. It occurs in mountain climbers, sailors at sea, astronauts in orbit, and people resting alone at night. For centuries, it was taken as evidence of spirits or invisible companions. Today, it is studied as a natural phenomenon of the brain's self-representation system. Reports of such sensations appear in every culture. Early polar explorers wrote of unseen companions who encouraged them through exhaustion. In clinical contexts, patients with epilepsy, Parkinson's disease, or migraine occasionally describe the same impression. Even healthy individuals, under conditions of isolation, stress, or fatigue, can feel another being nearby. The pattern suggests that the phenomenon does not require external cause, but arises from the interaction of perception, movement, and emotion within the nervous system. The first systematic studies came from neurology. In the 1990s, physicians noticed that stimulation of certain regions in the temporoparietal junction could induce an immediate sense of presence. The subject would report, calmly but firmly, that someone was close, often mirroring their own posture. The intruder felt real yet intangible, sharing the same physical space. Functional imaging later confirmed that this region integrates sensory signals from vision, touch, and proprioception, the brain's awareness of the body's position. When integration falters, the model of self in space splits, and part of the self is perceived as other. This mechanism explains why the presence often mimics the experiencer's movements. In laboratory settings where robotic interfaces reproduce a subject's gestures with a slight delay, participants begin to sense another entity following them. The lag confuses predictive signals between motor commands and feedback, creating an externalized double. The illusion fades when the timing is restored. Such experiments reveal how finely tuned the brain's sense of agency is. Even a few hundred milliseconds of mismatch can separate me from not me. Emotion amplifies the effect. Fear, grief, or loneliness heighten vigilance and increase activity in brain circuits that detect agency, the same systems once needed to notice predators in the dark. When the environment is silent or ambiguous, those circuits may generate false positives. The amygdala and anterior cingulate cortex, regions involved in threat monitoring, raise physiological arousal, while the parietal cortex interprets vague bodily cues as evidence of another's nearness. The result is a full-body perception, not a thought. The heartbeat quickens. The skin cools. It feels as if someone has stepped into the room. Cultural interpretation shapes the experience afterward. In some traditions, the unseen companion becomes a guardian spirit. In others, a ghost or ancestral soul. Mountaineers have called it the third man factor, sailors the phantom watchman. The brain supplies the sensation, and belief supplies the story. Anthropologists note that these narratives often carry positive meaning. They transform isolation into connection and fear into guidance. The physiology is universal, the symbolism local. Neuroscience situates this phenomenon within a broader framework known as bodily self-consciousness. The brain maintains a constantly updated map that combines tactile input, motor signals, and spatial orientation. This map underlies the sense that we occupy a particular body at a particular place. Disruptions through fatigue, hypoxia, or neurological disorder can produce sensations of doubling, floating, or separation. A feeling of presence is one variant of this disturbance. A mild and temporary misalignment between predicted and actual sensory feedback. Modern research extends these findings with virtual reality experiments. By manipulating visual or tactile delays, scientists can induce controllable presences in volunteers. Participants know the setup is artificial, yet their bodies react instinctively. Heart rate rises, skin conductance changes, and movement slows. These responses confirm that the perception is embodied, not imagined. Awareness of the illusion does not dissolve its power, much as understanding a visual illusion does not make it disappear. From a psychological perspective, the experience serves adaptive functions. The brain's bias toward detecting agents ensures safety in uncertain environments. It is better to imagine a companion than to overlook a potential threat. This principle, sometimes called the hyperactive agency detection system, explains both evolutionary survival advantages and cultural stories of spirits, guardians, or deities. When the mind extends itself outward to interpret subtle cues, it populates the world with meaningful others. The sense of presence, then, is not an error, but an overextension of a normally protective system. In clinical settings, stronger or more persistent presences can accompany conditions like schizophrenia or post-traumatic stress. For these individuals, the boundary between self and environment remains fragile. Neuroimaging shows hyperconnectivity between sensory and emotional regions, suggesting that internally generated signals acquire external significance. Understanding this mechanism has led to therapeutic approaches that reduce misattribution by training awareness of bodily cues and emotional states. Grounding the experience in physiology can replace fear with comprehension. There is also a gentler side to the phenomenon. After bereavement, many people report sensing the deceased nearby through voice, touch, or atmosphere. Studies find that such post-bereavement presences are common and usually comforting. They often fade naturally as grief resolves. Psychologists interpret them as the mind's way of preserving attachment while adjusting to absence. Neural patterns linked to memory and imagination reactivate in sensory areas, creating a vivid impression of company. The emotion is real, even if the source is internal. Physiological states, such as sleep deprivation, hypoxia, and low blood sugar can also trigger presence sensations. High-altitude climbers, deprived of oxygen and sensory input, frequently describe vivid companions who walk beside them or offer encouragement. The combination of stress hormones, disrupted proprioception, and reduced visual clarity favors projection. Similar effects appear during certain meditation or trance practices where attention turns inward and external boundaries blur. Whether interpreted as spiritual or neural, the underlying process remains consistent. The self becomes temporarily duplicated in perception. Technological studies provide finer detail. Electroencephalography shows changes in beta and gamma, oscillations during induced presences frequencies associated with sensory motor integration. These shifts correspond to altered connectivity between frontal prediction areas and posterior sensory regions. In simple terms, the brain's internal model of the body momentarily loses synchronization with incoming signals. When the mismatch exceeds a threshold, a secondary representation emerges. Perceived as someone else, the event lasts seconds, but leaves a lasting impression of mystery. Philosophers of mind find in this phenomenon a lesson about consciousness itself. The feeling of presence reveals that selfhood is not a single entity, but a dynamic construct maintained through prediction and feedback. When the system simulates itself, it can mistake part of that simulation for another being. The discovery is humbling. The boundary between I and you may be thinner than intuition suggests. Even solitude contains traces of relation, built into the architecture of awareness. For most people, such moments pass quickly. Turning on a light, hearing a familiar sound, or focusing on concrete details restores integration. The sensory system recalibrates, and the phantom companion dissolves into normal perception. Yet the memory remains unusually clear, as if the experience carried emotional weight disproportionate to its duration. That clarity testifies to the brain's tendency to mark anomalies for later reflection and adaptive learning, signaled to refine its internal model. The study of presence sensations continues to grow, bridging neuroscience, psychology, and anthropology. Future work explores how these experiences relate to creativity, empathy, and social cognition. Some researchers suggest that the same neural flexibility enabling presences also supports our ability to imagine. Others thought a cornerstone of human cooperation. In that sense, the ghost in the room may be a distant relative of the mind that allows us to understand each other. Realizing this connection changes how we interpret the extraordinary. The presence that once inspired fear can instead evoke curiosity. It reminds us that perception is not merely reception, but participation, a dialogue between body and world, self and simulation. The unseen companion becomes a reflection of our own complexity, a signal from the deep circuitry that keeps consciousness whole. And as the sense of company fades, another question arises naturally. If the brain can project presences into waking life, what happens when it drifts towards sleep, where the line between imagination and reality softens even more? In that twilight boundary, the same mechanisms give rise to a different yet related phenomenon, sleep paralysis, where the mind awakens before the body and dreams spill into awareness. Sleep is not a single state, but a rhythm of alternating patterns, cycles of light and deep rest, of silence and inner activity. During the night, the brain moves through stages, that restore the body while maintaining a hidden theater of perception. One of those stages, known as rapid eye movement or REM sleep, is when most vivid dreams occur. In REM, the cortex is almost as active as in wakefulness, yet the body lies still. This paradox in alert mind, within a motionless frame, reveals much about how consciousness operates. Paralysis occurs when the coordination between those two systems briefly falters. The mind awakens while the body remains under the muscle atonia that normally prevents movement during dreams. The person opens their eyes, senses the room, but cannot speak or move. Breathing feels shallow because the chest muscles are still partially inhibited. The experience lasts seconds or minutes, but can feel timeless. In that interval, dream imagery may overlap with waking perception, producing vivid hallucinations of presence, pressure, or movement. Throughout history, these episodes have inspired myths of nocturnal visitors, demons, or spirits pressing on the chest, the old hag of European folklore, the Kaneshibari of Japan, the Pesadera of Brazil. Modern neuroscience explains the sequence in physiological terms. During REM sleep, neurons in the pons release inhibitory signals through the spinal cord that silence motor neurons. This mechanism prevents us from acting out dreams. When consciousness returns before the inhibition lifts, the mismatch creates paralysis. At the same time, parts of the amygdala and parietal cortex remain active, maintaining the vivid imagery and emotional tone of dreaming. The combination of immobility and residual dream content gives rise to intense sensations, often visual or tactile, sometimes auditory. Studies using electroencephalography show that during paralysis, brain waves display a hybrid pattern: fast alpha and beta rhythms of wakefulness, mixed with theta waves typical of REM. The thalamus continues to relay sensory input, but cortical interpretation still follows dream logic. This overlap explains why people describe the scene as half real. Half unreal, the bedroom seems accurate, yet infused with impossible details. Lights shimmer, sounds distort, shapes hover at the edge of vision. The state demonstrates that perception is not binary. Consciousness transitions through gradients, not switches. Fear is common in these moments. The body's immobility triggers a surge of sympathetic activity, the same system responsible for the fight or flight response. Heart rate increases, and carbon dioxide buildup intensifies the sense of suffocation. The amygdala, interpreting the physiological alarm, constructs a matching narrative. If the body feels threatened, there must be a threat. Hence the frequent perception of a figure sitting on the chest or standing nearby. The mind externalizes internal stress into an imagined source. Once movement returns and breathing deepens, the figure disappears, dissolving as the systems realign. Epidemiological studies suggest that at least 1 in 5 people experience sleep paralysis at some point. It is more frequent in students, shift workers, and individuals with irregular sleep schedules, conditions that disrupt circadian timing. It also correlates with anxiety, post-traumatic stress, and narcolepsy. In narcolepsy, boundaries between sleep stages blur. REM intrudes into wakefulness, producing both paralysis and sudden dream imagery known as hypnagogic or hypnopompic hallucinations. These experiences can be frightening, but are medically benign. Recognizing their mechanism often reduces their emotional impact. Researchers have mapped how cultural interpretation shapes emotional outcome. In societies where paralysis is attributed to supernatural attack, sufferers report higher levels of distress and longer episodes. Where it is explained as a physiological event, fear diminishes. Education alone can change the experience. Knowing that the body is temporarily immobilized by its own safety system transforms terror into observation. Some people learn to use the state as a bridge into lucid dreaming, maintaining awareness while the body remains still. From a cognitive perspective, sleep paralysis demonstrates how easily the brain can blend internal and external realities. During transition between sleep and wake, sensory input competes with the vivid imagery generated by the visual association cortex. The intruder hallucination activates face processing areas. The pressure on the chest arises from misinterpreted interoceptive signals of restricted breathing. Experiments with virtual reality simulations that reproduce these sensations show similar emotional responses even when participants know the cause. Awareness of the mechanism does not cancel the feeling, reminding us that emotion precedes reasoning in the brain's hierarchy. Physiologically, the experience ends when serotonin and norepinephrine activity resume in the brainstem, lifting muscle inhibition. The return of voluntary movement is abrupt, followed by rapid normalization of breathing and heart rate. Many people sit up immediately, as if breaking through water. Others remain still, absorbing the quiet after the storm of sensation. The body resets within seconds, but the memory lingers with unusual clarity. Functional imaging suggests that the hippocampus marks the episode as salient, reinforcing recall. This may explain why single experiences remain vivid for decades. Scientists studying sleep paralysis see it as a key to understanding consciousness. It exposes the machinery that separates dreaming from waking, revealing how perception, emotion, and motor control are synchronized. By observing when that synchronization fails, researchers glimpse how the sense of agency is constructed. The same principles apply to other border states, hypnagogic imagery before sleep, false awakenings, or lucid dreams, where elements of different consciousness modes overlap. Together, they show that awareness is not located in a single place, but emerges from coordination among many networks. Preventive strategies focus on stabilizing sleep patterns, maintaining consistent bedtimes, reducing caffeine, and minimizing light exposure before sleep-reduce episodes. Stress management also matters. Relaxation before bed lowers amygdala activity, making partial awakenings less likely to escalate into fear. For most people, such episodes are rare and self-limiting. When chronic, they respond to treatments that improve REM regulation, such as certain antidepressants or behavioral adjustments. Beyond its clinical aspect, sleep paralysis has cultural and artistic resonance. Painters of the Romantic era captured it as a symbol of unseen pressure, while writers used it to explore boundaries of consciousness. In modern media, the phenomenon often appears as horror, though its scientific explanation is mundane. Yet even stripped of mythology, it remains deeply human, a reminder that our most private sensations can become entire worlds when consciousness shifts by a fraction. Understanding this experience invites a gentler relationship with the unknown. The same system that sometimes traps us in immobility also creates the rich landscapes of dreams. What feels like intrusion is often the mind watching itself. When movement returns and morning light enters the room, the memory of paralysis fades into curiosity. It becomes part of the broader story of how the brain navigates transitions, balancing reality and imagination. And just as the sleeping mind can merge memory and present sensation, the waking mind can blur past and present, creating echoes of recognition that feel both strange and familiar. From the stillness of sleep, we now turn to another subtle distortion of perception, one that occurs not at night, but in the middle of ordinary life. The experience of déjà vu, when the moment we are living seems to have happened before. Almost everyone has felt it. a brief, uncanny conviction that the present moment has already happened. The light, the angle of a face, a fragment of conversation. Everything feels duplicated, as if reality were repeating itself. This is déjà vu, literally already seen. It lasts only seconds, yet leaves a lasting impression of mystery. A rarer and deeper variant, déjà vécu, already lived, extends the illusion into an entire sequence of events, as though one were reenacting life itself. These experiences seem paranormal, but their roots lie in the normal workings of memory and prediction inside the temporal lobes. Early thinkers speculated that déjà vu reflected reincarnation, parallel worlds, or prophetic insight. In the 19th century, however, neurologists began to suspect that the sensation originated in the brain rather than the cosmos. Patients with temporal lobe epilepsy sometimes reported intense déjà vu just before seizures, suggesting that brief electrical disturbances in memory circuits could produce familiarity without genuine recall. Modern imaging supports this view. During induced déjà vu, activity spikes in the hippocampus and adjacent parahippocampal cortex regions, responsible for recognizing places and events. The feeling of familiarity, it seems, can be triggered independently of factual memory. To understand why, it helps to consider how recognition normally works. When we encounter a scene, sensory information flows to the hippocampus, which compares it with stored patterns. If a match is found, we experience recollection. If the match is partial, we experience familiarity, a subtle, "I know this." Déjà vu arises when the familiarity signal fires strongly, even though the current situation is new. The brain declares recognition without evidence. It is, in essence, a false positive in the system of memory verification. One hypothesis links this error to dual processing of perception. Visual and auditory input travel through parallel pathways that usually converge synchronously. A slight delay in one pathway caused by fatigue, distraction, or irregular firing might make the second arrival feel like repetition of the first. The brain interprets the lag as memory rather than latency. Experiments using divided attention tasks support this idea. When participants process similar stimuli twice in quick succession, they are more likely to report déjà-like feelings. Another model focuses on prediction. Because perception is based on expectation, the brain continually forecasts what will happen a few milliseconds ahead. If prediction aligns perfectly with input, the experience feels fluent and familiar. Some researchers propose that déjà vu occurs when predictive accuracy becomes unusually high, producing a surge of confidence detached from actual memory. Functional MRI studies show that the same networks active during genuine recognition, the hippocampus, anterior temporal cortex, and prefrontal regions activate during déjà vu, but without the detailed recollective patterns seen in true recall. The system registers familiar, while failing to retrieve specifics. Psychologists studying memory illusions note that déjà vu often appears during moderate stress or fatigue conditions that slightly disrupt encoding of new information. When attention fluctuates, the first perception of a scene may be too weak to register consciously, yet strong enough to prime recognition a few moments later. When the eyes or head move back, the scene re-enters awareness, and the primed trace gives it a false aura of repetition. This partial encoding hypothesis explains why déjà vu is more common in novel environments filled with subtle symmetry. The brain mistakes structural similarity for repetition, a rarer and more persistent form. Déjà vécu involves entire episodes of life feeling duplicated. Neurologist Chris Mullan described, patients who believed that every daily event had already happened, and sometimes refused to perform ordinary actions because there is no point I've done this before. Neuropsychological tests show that these individuals suffer from dysfunction in source monitoring, the ability to distinguish between imagined and experienced events. Damage to the frontal temporal network causes the familiarity system to dominate unchecked by logical evaluation. The result is a chronic false certainty. For most people, however, déjà vu is brief and harmless. Surveys indicate it peaks in young adulthood and declines with age, possibly reflecting the flexibility of memory circuits and the novelty of experiences. It is also more frequent in individuals who travel, read fiction, or engage in vivid daydreaming activities that expose the brain to diverse spatial and narrative patterns. The more templates memory holds, the greater the chance of coincidental overlap. The sense of repetition may therefore be a side effect of an efficient, richly associative mind. Beyond neurology, déjà vu offers insight into how memory constructs the feeling of continuity. Memory is not a recording, but a reconstruction guided by confidence signals. Each time we recall an event, the trace is rewritten with present emotion and context. Familiarity acts as a quick heuristic and internal gauge of certainty, normally reliable but occasionally miscalibrated. When that calibration slips, the brain momentarily mistakes new experience for remembered experience. The eerie clarity of déjà vu reflects the precision of that false calibration. Imaging studies deepen the picture. During experimental induction, often using virtual reality scenes that share spatial geometry but differ in content, participants report déjà vu in the parahippocampal cortex signals familiarity, while the hippocampus, responsible for detailed recall, remains silent. A disconnect between the two regions produces the paradox of knowing without knowing why. Electrical stimulation of the medial temporal lobe reproduces the same sensation, confirming its neural origin. Philosophically, déjà vu touches the boundary between time and consciousness. It reveals that the brain does not experience the present as an isolated instant, but as a moving window integrating past predictions and incoming data. When synchronization slips, perception folds over itself, creating a brief loop of awareness. The mind perceives its own echo. Some researchers liken it to a short circuit in the system that keeps experience linear. The temporal lobes, acting as editors of continuity, momentarily replay a fragment before advancing. Emotion influences the tone of the event. When accompanied by calm, déjà vu can feel intriguing or even pleasant, producing a mild sense of harmony with the environment. Under stress, it can feel ominous, as if reality itself were fragile. These differences depend on limbic activation. The amygdala colors the neutral signal of familiarity with affect, assigning meaning after the fact. Understanding this interplay helps explain why cultural interpretations range from mystic insight to warning omen. The underlying mechanism is the same. Only emotion changes the story. There is also a cognitive mirror image known as jamais vu, never seen. Here, familiar surroundings suddenly feel strange, as if recognized places or words have lost meaning. It arises from temporary desynchronization in the opposite direction. The recognition system under-responds, creating novelty where there should be familiarity. Together, déjà vu and jamais vu mark the brain's constant calibration between memory and perception. They show that reality, for us, is always filtered through confidence levels rather than raw data. Study persistent déjà vu to better understand temporal lobe function. Its occurrence in epilepsy and dementia provides clues to how neural circuits encode and retrieve contextual information. In mild cases, the phenomenon offers reassurance that the machinery of recognition is working, perhaps too eagerly, but working nonetheless. The same predictive circuits that let us navigate the world occasionally misfire, producing beauty instead of confusion. Within that fleeting error lies evidence of the system's sophistication. Seen through the lens of calm science, déjà vu is not a supernatural glitch, but a gentle reminder of how the brain knits past and present into a seamless whole. It exposes the precision and fragility of the mechanism that grants continuity to consciousness. For a moment, we catch ourselves in the act of constructing reality, and then the feeling fades, leaving only curiosity. And as the echo of familiarity quiets, another internal voice often rises, the silent commentary that accompanies thought itself. From déjà vu, where memory speaks out of turn, we turn to the inner voice, the constant presence that narrates our lives and sometimes feels separate enough to seem like someone else. Human thought is rarely silent. Beneath every action runs a stream of inner dialogue sentences we never say aloud, fragments of rehearsal, quiet reminders of what matters. This inner voice is so constant that most people forget it exists until it grows loud or turns against them. Understanding how the brain produces that voice offers a glimpse into the machinery of consciousness itself, how we translate abstract intention into language and sometimes mistake that language for something external. The foundation of inner speech lies in the same neural systems that support ordinary conversation. When you plan a sentence silently, regions such as Broca's area in the left inferior frontal gyrus and Wernicke's area in the temporal lobe activate almost exactly as they do during audible speech. Signals travel through the arcuate fasciculus, connecting comprehension and production centers. The difference is that during internal speech, the motor cortex sends commands that are largely inhibited before they reach the muscles of the tongue and larynx. The brain predicts the sensory outcome of speaking, but cancels the execution. What remains is the echo of language inside awareness. Neuroing confirms this pattern. Functional MRI studies show bursts of activity in speech planning areas, even when participants simply read silently or think in words. Subtle electrical potentials, measured in the muscles around the mouth, reveal micro-movements, tiny contractions lasting milliseconds that correspond to the imagined articulation. The body whispers what the mind intends to say. This physiological trace explains why inner speech feels embodied. It is not a purely abstract phenomenon, but a rehearsal of real motion restrained at the final moment. Inner speech serves several cognitive functions. It organizes working memory, helps in problem solving, and regulates emotion. Children acquire it gradually. Developmental psychologist Lev Vygotsky observed that young children often speak to themselves aloud while playing, narrating their actions. As language and self-control mature, this external monologue moves inward, becoming the silent companion of thought. Through it, the child learns to guide attention and plan sequences of behavior. In adulthood, the same mechanism underlies self-reflection and decision-making. Not all inner speech sounds alike. Some people report hearing it as their own neutral voice. Others experience it as dialogic, containing multiple perspectives or distinct tones. Studies using questionnaire and experience sampling show wide variation. Individuals who frequently engage in creative writing or social imagination tend to have more elaborate internal dialogues, possibly because they simulate multiple conversational partners. The diversity suggests that the voice within is not a single structure, but a flexible workspace where linguistic, emotional, and auditory networks meet. Sometimes this system blurs the boundary between internal and external sound. In conditions such as schizophrenia or severe stress, the predictive mechanism that labels self-generated speech as internal can malfunction. Normally, when the brain sends a motor command to produce speech, it issues a parallel corollary discharge, a signal predicting the sensory feedback. This prediction dampens the auditory cortex's response, letting us distinguish self-made from external noise. When the damping fails, inner speech may be perceived as coming from outside. The resulting auditory verbal hallucinations feel like actual voices, though they originate in the same circuits that generate thought. Research using magnetoencephalography shows that during such hallucinations, activation in speech areas precedes activation in auditory cortex, precisely the order seen in self-generated speech. The difference lies in monitoring. The brain does not recognize the source as self. This finding reframes hallucinated voices not as alien invasions, but as misattributed inner dialogue. The content often mirrors emotion critical during guilt, comforting during loneliness, reflecting the speaker's own psychological state. Understanding this mechanism allows therapy to focus on integrating the voices rather than erasing them, helping patients regain ownership of their inner language, even outside pathology. The brain's ability to simulate sound is remarkable. When we recall a familiar melody or imagine a friend's voice, auditory regions reproduce their characteristic frequencies. The same neurons that respond to actual sound fire during vivid imagination. This overlap explains why internal hearing can feel so lifelike. Musicians training in mental rehearsal strengthen these circuits, improving performance without touching an instrument. The mind's ear, like the mind's eye, operates on shared neural ground with perception. Cognitive neuroscience distinguishes between two main forms of inner speech, condensed and expanded. Condensed inner speech is brief, almost schematic, a word or phrase standing for a complex idea. Expanded inner speech retains full sentences and a sense of dialogue. The balance between them shifts with task demands. During mathematical reasoning or spatial planning, inner speech may reduce to symbols. During moral reflection, it may unfold into conversation. This flexibility illustrates how language supports, rather than dictates, thought. The inner voice is both tool and mirror of cognition. Emotion strongly colors internal dialogue. Brain imaging reveals that the anterior cingulate cortex and insula, regions involved in self-evaluation and interoception, coactivate with language areas during self-talk. When inner speech becomes self-critical, these emotional centers amplify stress responses. Conversely, compassionate inner dialogue can downregulate amygdala activity, reducing anxiety. Cognitive behavioral therapies leverage this connection by teaching people to recognize and reframe harmful self-talk. The neural mechanism of kindness toward oneself is, quite literally, a change in tone within the mind. From a broader perspective, the inner voice represents the meeting point of language and consciousness. Philosophers have long debated whether thought requires words. Studies of individuals with aphasia language loss due to brain injury suggest that some forms of reasoning persist without verbalization, supported by imagery and intuition. Yet complex planning and moral deliberation often rely on verbal scaffolding. Words allow us to hold abstract concepts steady long enough to examine them. Inner speech, then, acts as the thread weaving attention through time, giving continuity to self. Interestingly, not everyone experiences constant internal narration. Some describe thought as visual or kinesthetic rather than verbal. Others report intervals of pure awareness without words, particularly during meditation. Functional imaging shows reduced activity in language areas during such states, along with increased coherence in sensory and attentional networks. Silence within the mind is not emptiness, but another mode of organization, one where perception replaces commentary. Alternation between verbal and nonverbal consciousness may be part of the brain's natural rhythm of regulation. Cultural attitudes toward the inner voice differ. In some traditions, it is viewed as conscience or moral guide. In others, as distraction to be quieted through mindfulness. Anthropological studies reveal that how people interpret inner speech, whether as self, spirit, or thought, depends on cultural frameworks for agency and personhood. The same physiological process can thus produce experiences labeled as prayer, intuition, or inspiration. Science does not rank these interpretations. It seeks the underlying mechanics that make them possible. From an evolutionary standpoint, internal dialogue may have developed from the need to simulate social interaction. Humans survive by predicting others' behavior. The ability to model another person's perspective uses similar neural circuits to those involved in talking to oneself. Over time, these simulations may have become internalized conversations, giving rise to reflective thought. In that sense, the inner voice is society miniaturized within the brain, a rehearsal hall for empathy and foresight. Modern technologies provide glimpses into this invisible speech. Researchers using electrocorticography have trained algorithms to reconstruct imagined words from neural activity patterns. Early results show partial decoding of phonemes, suggesting that brain-computer interfaces could one day translate inner speech into synthetic output. Such work raises ethical questions about privacy and identity, reminding us that the voice within is among the most intimate aspects of being human. Ultimately, the phenomenon demonstrates the continuity between perception, action, and thought. Speaking inwardly, hearing inwardly, and thinking inwardly rely on the same predictive cycles. When coordination is precise, the voice feels like me. When it slips, it can feel foreign or prophetic. Both outcomes arise from the same machinery that keeps us oriented in the social world. The inner voice is not a mystery to be solved, but a companion to be understood, a living example of how the brain constructs experience from its own activity. And as this internal conversation quiets, the senses turn outward again. The same mechanisms that let us hear within can project outward under different conditions, painting meaning onto shadows and patterns in the environment. From the dialogue of the self, we move to the visions of the world, the moments when light and uncertainty combine to create shapes that seem alive. Human vision is built to interpret, not to record. At night, or in uncertain light, the brain faces a puzzle of missing information and must decide what it sees before the details are clear. That speed is essential for survival, but it also opens the door to illusions, faces in the fog, motion at the edge of vision, shapes that seem alive. Throughout history, these moments have been called hauntings, apparitions, or omens. Today they are understood as the natural result of perception working at its limits. The phenomenon known as pareidolia lies at the heart of this process. It is the tendency to perceive meaningful patterns, especially faces within random stimuli. A cluster of leaves, a pattern on the wall, the folds of a curtain, each can trigger the same neural circuits that recognize human features. Functional MRI shows that the fusiform face area activates even for abstract arrangements of eyes and mouths. The response is rapid, automatic, and emotionally charged. Evolution favored minds that erred on the side of detection. Mistaking a shadow for a person was safer than overlooking a real threat. The cost of vigilance is false positives, Low light magnifies this effect. The retina contains two main types of photoreceptors: cones, which detect color and detail under bright conditions, and rods, which are more sensitive to movement but provide little resolution. In darkness, rods dominate. Their signals feed pathways tuned to motion and contrast rather than clarity. As a result, peripheral vision becomes active while central focus weakens. When a faint movement or flicker occurs at the edge of sight, the brain fills in a plausible form. The mind completes the picture before evidence arrives, and a shapeless blur becomes a silhouette. Sound and touch can join this pattern. In quiet rooms, subtle noises, air expansion in pipes, muscle twitches, changes in blood flow become amplified. The auditory system, seeking context, groups them into recognizable sources. A creak resembles a step. A pulse in the ear becomes a whisper. These cross-modal integrations keep perception coherent, but can easily mislead. The brain prefers a coherent story to ambiguity. When multiple senses supply uncertain data, it fuses them into a single cause, often anthropomorphic. Emotion heightens this sensitivity. Fear increases activity in the amygdala and periaqueductal gray, regions that prime defensive attention. Under anxiety, the threshold for detecting threat drops. A rustle or reflection that might be ignored in daylight becomes significant in the dark. The resulting cascade, adrenaline, faster heart rate, narrowed focus, reinforces the sense that something is present. The physiology of danger perception translates directly into the psychology of haunting. Cultural background provides the vocabulary for these sensations. Where spiritual or ancestral beliefs are strong, ambiguous perceptions become evidence of other worlds. In secular settings, they are framed as psychological or physical anomalies. Anthropologists emphasize that both interpretations fulfill similar needs. They organize uncertainty and restore a feeling of control. What changes across cultures is not the experience itself, but the narrative used to explain it. Environmental factors can also shape perception. Low-frequency vibrations below the threshold of hearing infrasound cause subtle effects on vision and balance. Frequencies around 19 Hz can resonate with the eyeball, producing shimmering in the peripheral field. Experimental exposure to infrasound increases reports of unease and visual shadows, even in otherwise calm rooms. Similarly, carbon monoxide leaks, toxic molds, or electromagnetic fields from faulty wiring have been linked to sensations of presence or visual distortions. These physical influences remind investigators that haunting experiences often have tangible, environmental roots. Neuroscience connects these external conditions to internal processing. The temporal and parietal lobes integrate visual, auditory, and somatic information into a spatial map of the body and surroundings. When activity in these areas becomes irregular through stress, fatigue, or lack of oxygen, the boundaries of self and environment blur. The same misalignment that produces the feeling of presence can also generate fleeting apparitions. In laboratory experiments, electrical stimulation of these regions evokes shadows or doubles that mimic the subject's posture. The ghost, in these moments, is the brain observing its own representation. Another contributor is the brain's predictive coding system. When sensory input is ambiguous, higher-level expectations dominate perception. If one enters a dark building expecting something uncanny, the top-down predictions bias interpretation of every sound and flicker. This is why haunted locations reliably produce more reports of anomalies than identical control sites. Expectation literally reshapes perception by weighting prediction over data. Understanding this loop reveals how belief and physiology cooperate to create vivid, Self-consistent experiences. Memory adds another layer. The hippocampus associates places with emotion. Returning to a setting charged with fear or grief reactivates those feelings even before any stimulus appears. The past overlays the present, tinting perception with significance. What feels like a supernatural atmosphere may be emotional memory resurfacing through context cues, the smell of dust, the acoustics of a hallway, the temperature of stone walls. The brain replays emotion as sensation. Despite these mechanisms, the experience of seeing a figure or shadow remains powerful. Physiologically, the image is real in the sense that the same visual cortex regions fire as they would for an external person. The difference lies in origin, not in vividness. For the observer, the boundary between imagination and perception disappears. Such events demonstrate the constructive nature of vision. The eyes deliver signals, but the brain decides their meaning. Scientists who study visual misperception emphasize that illusions are not malfunctions, but side effects of a system optimized for speed and survival. Every second, the visual cortex processes vast amounts of information and compresses it into a coherent model. Under normal conditions, prediction and input align. In dim light or stress, prediction takes the lead. That same adaptability allows us to navigate safely, read expressions, and recognize patterns. Occasional errors are the trade-off for efficiency. Understanding these dynamics has practical applications. Architects designing low-light environments, pilots training for night flight, and safety engineers all account for the brain's tendency to misinterpret ambiguous stimuli. Awareness of pareidolia and expectation bias reduces accidents as well as superstition. In a subtler way, this knowledge also encourages empathy toward those who report extraordinary experiences. Their perceptions are genuine reflections of neurobiology, not evidence of irrationality. From a philosophical standpoint, the vision of a ghost reveals the brain's insistence on meaning. Confronted with uncertainty, it prefers story over void. This same drive fuels art, religion, and science alike, the impulse to find order in chaos. When we glimpse a shape in the dark, we witness that creative engine at work. The ghost is the mind's projection onto an incomplete canvas dot as technology advances. Researchers use virtual reality systems to study these perceptual thresholds. By adjusting lighting, delay, and feedback, they can reliably induce feelings of presence or fleeting forms. The results confirm that the machinery of haunting is the machinery of perception itself. Understanding it does not strip the world of wonder. It relocates wonder inside a dot when the lights return to normal and the edges of the room sharpen. The figures dissolve, leaving only curiosity. The same neural circuits that conjure shapes from shadows also support imagination, empathy, and anticipation. They remind us that seeing is never merely receiving, it is participation. Vision, like thought, is an act of creation, and as we leave the realm of fleeting forms, our attention turns inward again to states where perception and self-awareness shift more profoundly, not from darkness, but from the rhythms of the mind itself. Trance, meditation, and altered consciousness reveal how far the boundaries of ordinary experience can stretch while remaining within the physiology of the human brain. Consciousness is not fixed. It ebbs and flows across a spectrum of states, from focused attention to daydream, from sleep to deep absorption. Between waking and dreaming lies a wide territory that neuroscience calls altered states of consciousness. They include hypnosis, meditation, prayer, rhythmic movement, and trance. In these moments, the structure of awareness changes. Perception narrows or expands. Time slows, and the sense of self can soften or dissolve. Such states have been part of human life for millennia, interpreted as spiritual experience, inspiration, or communion. Modern science explores them as natural expressions of how the brain modulates its own activity. The concept of trance refers broadly to a condition in which attention becomes highly focused and responsiveness to external stimuli decreases. This can occur through repetition of sound, movement, or breath, or through intense concentration on a single idea or image. Anthropologists studying rituals in diverse cultures have documented strikingly similar techniques: drumming, chanting, swaying, or controlled breathing. These actions rhythmically stimulate sensory and motor systems, entraining neural oscillations across the brain. As rhythmic input synchronizes regions that normally operate independently, a distinctive pattern emerges: reduced activity in the frontal cortex and enhanced connectivity in networks associated with emotion and body awareness. Electroencephalographic studies show that during trance, alpha and theta waves dominate, reflecting relaxed yet alert attention. In deeper stages, slow delta activity may appear, similar to light sleep, but without full loss of awareness. Functional imaging reveals decreased blood flow in the default mode network set of midline structures involved in self-referential thought and increased activity in sensory and limbic areas. The result is a shift from narrative self-awareness, "I am doing this," to embodied immediacy, "This is happening." Participants often describe a feeling of unity, timelessness, or absorption in the present moment. Hypnosis represents one scientifically studied form of trance. Contrary to popular portrayals, hypnosis does not involve surrendering control, but redistributing it. Under guided suggestion, the brain's executive regions temporarily cede authority to imagery and expectation. Neuroimaging shows altered connectivity between the dorsolateral prefrontal cortex and the anterior cingulate cortex, regions that manage intention and monitoring. This reconfiguration allows suggestions to bypass habitual skepticism. In experiments, hypnotized participants can experience sensory changes, seeing color where there is none, or reducing pain perception, accompanied by corresponding changes in neural activity. The brain responds to imagined input as if it were real, demonstrating the power of top-down modulation. Meditative and contemplative practices produce related effects through sustained attention rather than external suggestion. Long-term meditation alters both structure and function of the brain. Studies of experienced practitioners show thicker cortical areas in regions linked to emotional regulation and interoception. Functional scans reveal decreased activity in the amygdala during stress and greater synchronization between prefrontal and insular regions. Subjectively, practitioners report calm clarity, reduced reactivity, and a subtle sense of distance from thoughts. The physiological basis lies in enhanced parasympathetic tone and balanced neurotransmitter release, including serotonin and gamma-aminobutyric acid, trance states induced by rhythm or dance. Common in communal rituals highlight another dimension: synchronization across individuals. When groups move or chant together, their breathing, heart rates, and neural oscillations can align. This phenomenon, sometimes called interpersonal entrainment, strengthens social bonding and collective emotion. In this sense, trance is both neurological and social. It dissolves boundaries not only within the self, but between people. Evolutionary psychologists suggest that such collective absorption once played a role in group cohesion and cooperation, transforming isolated individuals into coordinated communities. Altered states also occur spontaneously. During prolonged running, music immersion, or creative flow, The brain exhibits patterns resembling light trance, reduced prefrontal activity, increased dopamine release, and narrowed temporal perception. These states are associated with pleasure and effortless performance. They reveal how ordinary activities can momentarily silence the internal narrator, allowing direct engagement with experience. The boundaries between art, sport, and meditation blur at the level of neurophysiology. Pharmacological agents, psychedelics such as psilocybin, LSD, or DMT induce more dramatic alterations by acting on serotonin receptors, particularly 5-HT2A. Under their influence, cortical networks that normally maintain rigid segregation become fluid. Connectivity between sensory, emotional, and associative areas increases, while the default mode network temporarily fragments. This correlates with the dissolution of ego boundaries and the emergence of vivid imagery. Contemporary research revisits these substances not for their mystique, but for their therapeutic potential in depression, addiction, and existential anxiety. Controlled studies show that guided psychedelic experiences can reset maladaptive neural patterns, an effect described as neuroplastic reopening. Despite their controversy, these findings underscore that consciousness is a dynamic property of neural organization, not a fixed state. Across all these forms, hypnosis, meditation, rhythm, or chemistry, the underlying mechanisms share common principles. They alter the balance between internal prediction and external input, shifting the ratio of control. In ordinary waking life, perception is dominated by predictive coding. The brain constantly anticipates and corrects sensory data. In trance, predictive suppression loosens. Incoming sensations or imagery gain influence. This explains the vividness of mental imagery and the sense that thoughts acquire independent life. The experience may feel supernatural, yet it reflects a measurable change in top-down regulation. Clinically, altered states are being harnessed in new therapies. Hypnotic suggestion aids pain management and anxiety reduction. Mindfulness training improves attention and emotional resilience. Music and movement-based interventions use rhythmic entrainment to support motor recovery after stroke or Parkinson's disease. These applications demonstrate that shifting consciousness is not escapism, but adaptation and natural capacity the brain can use for healing. Not all altered states are beneficial. Extreme deprivation, hyperventilation, or sensory overload can provoke disorientation or panic. When feedback between prediction and sensation collapses, hallucinations may arise. The boundary between adaptive trance and pathological dissociation depends on context, safety, and intention. Cultural frameworks that guide and interpret the experience ritual structure. Supportive community. Preparation help maintain balance. The same mechanisms that enable transcendence can, in isolation, produce distress. Science thus treats altered consciousness not as anomaly, but as variation on a continuum whose meaning depends on environment and purpose. Philosophically, studying these states challenges the idea of a single normal consciousness. The mind is a dynamic system capable of reorganizing itself across many modes. Each reveals different facets of cognition: the analytical, the intuitive, the integrative. Rather than opposites, reason and trance are complementary expressions of the same biology. In calm focus or deep absorption, the brain explores its own flexibility, demonstrating that consciousness is less like a light switch and more like a dimmer gradual, adjustable, responsive to rhythm at the deepest level. These states show that the self we take for granted is a process, not an object. When attention detaches from ordinary narrative, perception becomes fluid, unbound by familiar categories. Whether through meditation or music, trance suspends the habitual separation between observer and observed. The world feels whole, continuous, self-sustaining. From a scientific viewpoint, this unity is the synchronization of neural networks. From a human viewpoint, it is peace. As understanding grows, researchers continue to map the borders between waking, dreaming, and trance. Each border crossing reveals more about how consciousness integrates body, emotion, and environment. The goal is not to reduce wonder, but to understand its architecture, to trace how a finite brain produces infinite experience. And as this exploration of shifting awareness unfolds, another frontier comes into view, one where consciousness itself flickers at the edge of survival. When the brain is deprived of oxygen or trauma pushes it to the limit, a different class of reports emerges. Visions of light, tunnels, and serenity. These are the near-death experiences, phenomena that bridge biology and existential mystery, inviting us to look closely at how the mind meets the threshold of life. When the body approaches the limits of survival, consciousness often behaves in unexpected ways. People revived after cardiac arrest or severe trauma frequently describe vivid experiences, moving through a tunnel, seeing brilliant light, watching their own body from above, or feeling an overwhelming calm. These near-death experiences, or NDEs, have appeared in medical records for more than a century and in literature for millennia. They were once treated solely as signs of spiritual passage. Today they are examined as windows into how the brain functions at the edge of life. Typical end accounts include several recurring features: a sense of detachment from the body, altered perception of time, intensified emotions, panoramic memory, encounters with beings or deceased relatives, and a feeling of peace or unity. Surveys across cultures show remarkable consistency despite differences in belief. Roughly 1 in 5 people who survive cardiac arrest report some version of the experience. The universality suggests a biological foundation, though interpretations vary. Understanding begins with what happens in the brain when blood flow and oxygen decline. Within seconds of cardiac arrest, cerebral perfusion drops to near zero. Electrical activity in the cortex rapidly diminishes, yet not instantly. Animal studies show a brief surge of organized, high-frequency oscillations, particularly gamma waves, just before the flatline. These waves synchronize distant brain regions involved in perception and memory, producing what researchers call a final integration event. In humans, similar transient spikes have been recorded in monitored patients during resuscitation. Such bursts could generate vivid, hyperreal imagery even as consciousness fades. The sensation of moving through a tunnel may arise from the structure of the visual system. As oxygen falls, neurons in the retina and occipital cortex lose function from the periphery inward. The field of vision contracts to a bright central core, giving the impression of a narrowing passage toward light. Laboratory experiments simulating hypoxia reproduce this pattern. The light itself may come from spontaneous firing in visual pathways, intensified by neurochemicals such as glutamate that surge during stress. Feelings of detachment or floating correspond to disruptions in the temporoparietal junction, which integrates bodily position and spatial orientation. Electrical stimulation of this region can induce out-of-body experiences even in healthy volunteers. During trauma, altered blood flow and neurotransmitter imbalance may momentarily decouple these networks, allowing the brain's internal model of the body to drift away from physical signals. The observer perspective common in NDEs mirrors this neural uncoupling. Emotionally, The dying brain is flooded with chemicals that modulate fear and pain. Endorphins and dopamine create euphoria. Serotonin and anandamide influence perception and a sense of unity. These neurochemical cascades evolve to ease distress during critical injury. Functional MRI of subjects under extreme stress shows limbic activation, similar to patterns reported in meditative or mystical states. The boundaries between agony and transcendence narrow when the nervous system releases its final protective wave. Another component, the life review, involves rapid activation of memory circuits. The hippocampus and medial temporal lobes can discharge spontaneously under hypoxia, releasing fragments of autobiographical imagery. Because these regions are densely connected to emotion centers, recalled memories feel immediate and complete. People often describe seeing their entire life in an instant, which aligns with the brain's ability to retrieve multiple memory traces simultaneously. When inhibitory control weakens, from a psychological standpoint, NDEs also reflect the brain's effort to preserve identity under existential threat. The sense of calm and order may result from the prefrontal cortex attempting to reconcile conflicting signals from failing sensory systems. Cognitive models propose that the brain constructs a coherent narrative to maintain continuity, a final act of meaning-making. In this view, the experience is not hallucination in the trivial sense, but the ultimate expression of the mind's integrative function. Cultural expectations shape content. Western patients may report tunnels and lights. In other societies, gardens, rivers, or ancestral gatherings predominate. The underlying pattern transition, encounter, peace remains constant, but imagery conforms to learned symbolism. Anthropologists note that such motifs appear in initiation rituals and shamanic journeys, suggesting that humanity has long encoded the physiology of dying into story. The brain provides structure. Culture provides metaphor. Recent large-scale studies, such as the AWARE project led by Sam Parnia, have begun measuring consciousness during cardiac arrest. By embedding visual targets and auditory cues in hospital rooms, researchers test whether patients reporting out-of-body perception can recall external events. So far, verifiable perception beyond ordinary senses has not been confirmed. Yet the reports continue to intrigue because they reveal awareness during periods previously thought unconscious. Electroencephalographic recordings show residual, sometimes organized activity minutes after the heart stops, blurring the line between death and recovery. Philosophically, ND research challenges the assumption that consciousness ceases immediately with brain failure. Whether these moments reflect surviving neural activity or something more remains open, but science can trace the mechanisms that make them possible. The brain is capable of producing rich experience even in crisis, drawing on memory, emotion, and expectation to maintain coherence. What people later describe as transcendence may be the mind's graceful response to disintegration, a final synchronization before silence. Clinically, studying NDEs has practical value. Understanding the neurochemistry of serenity at death may guide palliative care, helping physicians manage fear and pain more effectively. Insights into oxygen deprivation and brain resilience also inform resuscitation techniques. The phenomenon reminds medicine that subjective experience continues even when measurable function seems absent, emphasizing the need for gentleness during emergency interventions. From a human perspective, the impact of NDEs often extends far beyond the event. Many survivors report reduced fear of death, increased empathy, and reoriented values. These lasting changes correspond to measurable shifts in stress reactivity and neural plasticity. Whether interpreted spiritually or biologically, the experience can transform personality. It reveals that meaning, not mere survival, is the final concern of consciousness. Science approaches the near-death frontier with humility. Instruments can measure blood flow, electrical potential, and neurotransmitters, but not yet the texture of awareness. What is clear is that the transition between life and death is gradual, layered, and more dynamic than once believed. In those moments when perception detaches from the body and light fills the inner field, the brain is performing its most intricate balancing, act-sustaining experience on the edge of extinction. As our understanding deepens, NDEs may lose their aura of impossibility, but not their wonder. They reveal how perception, memory, and emotion can merge into a single, coherent vision, even when the system itself is failing. The mystery is not that people see light when they die, but that a brain starved of oxygen still finds a way to create beauty. And as consciousness returns from that threshold or fades beyond it, the question naturally arises: if such vivid experience can occur in isolation, what does it tell us about communication between minds while alive? The next exploration turns to the idea of connection without words, examining telepathy, intuition, and the enduring human belief that thoughts themselves might travel across the invisible space between us. For as long as humans have communicated, we have wondered whether minds can reach each other without words. The idea of telepathy, the direct transfer of thought or emotion, has appeared in myth, religion, and science fiction alike. Despite its cultural weight, the search for evidence has remained elusive. Yet the fascination endures, not only because of mystery, but because it touches a real question at the heart of neuroscience. How separate are our minds? And how deeply are they connected through biology, empathy, and prediction? Early investigations into telepathy began in the late 19th century, when psychology was still forming as a discipline. Researchers of the Society for Psychical Research in London collected reports of coincidental thoughts, dreams, and premonitions. Experiments followed, most famously the card guessing. Studies of the 1930s led by J.B. Rhine at Duke University. Participants tried to identify symbols on hidden cards, the so-called Zener cards. Small deviations above chance were reported, but replication under stricter controls failed to confirm them. Statistical biases, sensory leakage, and selective reporting explained most results. Decades of repetition produced the same pattern: intriguing anecdotes. No reliable mechanism. From a scientific viewpoint, genuine telepathy would require energy transfer or information encoding outside known physical channels. No such medium has been detected. Electromagnetic fields generated by the brain are extraordinarily weak, billions of times smaller than those from household electronics, and decay within centimeters. Even highly sensitive magnetometers can barely detect them outside the skull. Quantum explanations occasionally surface in popular literature, invoking entanglement or non-locality, but these phenomena occur at scales and conditions incompatible with living tissue. The physical plausibility of telepathy remains unsupported. Still, the subjective sense of knowing what someone else is thinking is real and widespread. Neuroscience explains this through mechanisms of social cognition. The human brain evolved to anticipate others' actions by simulating them internally. The mirror neuron system, first discovered in primates, activates both when performing an action and when observing another perform it. This shared representation allows rapid prediction of movement and intention. When a friend reaches for a cup, your motor cortex echoes the gesture a fraction of a second ahead. Empathy and coordination depend on this silent resonance. It is not telepathy in the paranormal sense, but communication through finely tuned prediction. Language itself amplifies this connection. During conversation, the neural rhythms of speakers and listeners align, a process called neural entrainment. Functional MRI and EEG studies show that brain activity in two people engaged in dialogue can synchronize in frequency and timing. This alignment enhances comprehension and emotional rapport. The experience of being on the same wavelength is therefore literal. Oscillations in auditory and frontal regions lock together, creating a shared temporal frame. The phenomenon, once considered poetic, now has measurable correlates. Beyond direct interaction, humans excel at inferring others' mental states through subtle cues, micro-expressions, posture, tone of voice. The theory of mind network, spanning the medial prefrontal cortex and temporoparietal junction, allows us to model beliefs and emotions of others. When such inference happens quickly and unconsciously, it feels like intuition. Intuitive insight is not supernatural. It is rapid pattern recognition built on extensive experience. The brain's predictive coding compresses past observations into immediate judgments. What seems like a sudden flash of knowing is the output of long practice operating below awareness. Psychologists studying thin slice perception have shown that people can judge mood, trustworthiness, or relationship stability from mere seconds of observation, often more accurately than when given more time. These abilities rely on the integration of multiple weak signals, weighted by learned probabilities. In social environments, such fast inference offers adaptive advantage. When someone across a room meets our eyes, and we instantly sense hostility or affection, the process unfolds through statistical learning, not telepathic transmission. Brain-to-brain communication has nevertheless entered a new, literal phase through technology. In recent years, researchers have linked EEG and transcranial magnetic stimulation between participants, transmitting simple information, such as yes, no responses, or visual flashes, from one brain to another over the internet. The signals pass through machines, not air, but they demonstrate that neural patterns can be translated into digital code and received by another nervous system. The work highlights how far cooperation between neuroscience and engineering has advanced, while also underscoring how little spontaneous telepathy occurs without mediation. Cultural and psychological factors often blur the line between connection and coincidence. Humans are exceptional pattern seekers. We remember striking alignments and forget mismatches. Two friends thinking of each other before one sends a message feels remarkable, but statistical analysis shows that frequent communication naturally produces such overlaps. The emotional salience of coincidence amplifies recall. This confirmation bias explains why telepathic impressions seem personal and convincing, despite ordinary probabilities in clinical contexts. Experiences interpreted as mind reading sometimes accompany anxiety or psychosis. Neurocognitive studies attribute these to misattribution of self-generated thoughts, similar to mechanisms underlying auditory hallucinations. When the boundary between self and other becomes unstable, internal predictions are externalized. Understanding this process helps clinicians treat symptoms without judgment, emphasizing that the experience, though subjectively real, reflects disrupted self-monitoring rather than external control. At the opposite end of the spectrum lie collective emotional phenomena, crowd contagion, synchronized fear or joy, and shared attention during performance. These arise from physiological coupling through sensory feedback, voice tone, and micro-movements. Heart rate monitors show that audiences watching the same film can align their heart rhythms, and choirs singing together exhibit synchronized breathing and hormonal changes. Such biological harmonization fosters empathy and trust. The ancient dream of minds touching finds partial fulfillment in these embodied networks. Intuition, often grouped with telepathy, represents the internal dimension of this connectedness. Decision-making research shows that much of cognition occurs below consciousness. The somatic marker hypothesis, proposed by Antonio Damasio, describes how bodily states guide choices before reasoning articulates them. Emotional feedback from the insula and ventromedial prefrontal cortex acts as a rapid evaluation system. Intuitive feelings are the body's condensed summary of accumulated knowledge. Far from irrational, they are efficient when the environment matches prior experience. Problems arise only when intuition meets unfamiliar situations and overconfidently predicts based on incomplete data. Understanding intuition illuminates why telepathic beliefs persist. Both rely on unconscious inference that feels immediate and certain. When an intuitive judgment about another person proves correct, it can resemble mind reading. Evolution favored such speed. Anticipating others' actions meant survival. The line between accurate empathy and imagined communication is therefore thin. Telepathy, in cultural terms, may be humanity's poetic name for the precision of social intuition. Philosophers and cognitive scientists sometimes describe human consciousness as deeply social. From infancy, the mind forms within networks of attention, language, and imitation. Every sense, every emotion carries traces of others. Seen in this light, our separate minds are already intertwined through shared neural design and constant exchange of signals. The longing for telepathy may express an intuitive awareness of this interdependence, the fact that our thoughts are never fully isolated dot as neuroscience advances. It continues to dissolve the boundary between solitary and collective cognition. Brain-computer interfaces, social neuroimaging, and studies of group decision-making reveal that information flows through complex systems linking individuals. What once seemed mystical now becomes measurable synchronization. Yet even as science explains the mechanics, the subjective wonder remains, the feeling that understanding passes between people faster than words. That sense of connection is real, even if its mechanism is prediction rather than transmission dot in the calm light of evidence. Telepathy fades as a physical hypothesis, but endures as a metaphor for empathy, the quiet resonance that allows one mind to reflect another. Our thoughts do not leap through space, yet they meet through shared perception, memory, and emotion. The human brain, tuned for cooperation, generates communion from biology alone dot, and as this exploration of mental connection closes, attention turns to phenomena once thought even more tangible reports of objects moving on their own, knocks and disturbances without cause. From the inner dialogue of minds, we now move to the outer world of motion and energy, where psychology and physics converge in the study of so-called poltergeist activity and spontaneous physical events. Among all reported paranormal experiences, few are as dramatic as the poltergeist. Objects moving without touch, knocks echoing through empty rooms, lights flickering as if animated by unseen hands. The term, from German poltergeist, noisy spirit, suggests a supernatural force, yet the phenomena most often arise in ordinary domestic settings and fade as suddenly as they begin. For centuries, such events were attributed to restless souls. Today, psychologists, physicists, and sociologists study them as complex interactions of perception, environment, and emotion. Historical records of poltergeist activity stretch back to the 1st century. often linked to periods of social stress or adolescence within a household. Modern investigations began in the 19th and 20th centuries with researchers like William Roll and Nander Fodor, who treated the disturbances as expressions of human tension rather than external entities. They observed recurring patterns, rapping sounds, spontaneous object displacement, electrical interference, and an atmosphere of anxiety focused around a specific individual, frequently a teenager or young adult under emotional strain. Contemporary analyses describe these episodes as spontaneous psychokinetic claims, but most can be explained through natural processes amplified by expectation. Buildings expand and contract with temperature shifts, generating rhythmic knocks. Plumbing and air ducts carry vibrations that seem localized. Static electricity or faulty wiring causes flickering lights. Once attention is drawn to such noises, selective perception reinforces them, and ordinary sounds become evidence of agency. The mind's bias toward pattern and intention, the agency detection system, transforms coincidence into communication. Nevertheless, investigators sometimes encounter physical anomalies difficult to trace immediately. In those cases, psychological and environmental factors often converge. Stress alters perception and memory. Adrenaline sharpens some sensations while suppressing others. Under collective tension, families can enter states of shared hypervigilance, misinterpreting neutral events as coordinated. This dynamic resembles mass suggestion rather than deceit. Experiments in cognitive psychology show how easily groups synchronize expectation. When one member anticipates a sound, others often hear it even in silence. Poltergeist outbreaks, viewed through this lens, become social feedback loops between fear, attention, and environmental noise. A small subset of reports includes genuine movement of objects witnessed by multiple observers. Detailed studies reveal that such motion can result from unnoticed physical causes: air currents from opening doors, vibration from nearby traffic, or the minute impulses of elastic materials releasing stored tension. The brain's timing precision, limited to about 1/10 of a second, can also misattribute cause and effect. An object shifting after a noise feels simultaneous with it. Once a supernatural frame is applied, each new motion reinforces belief. Psychological profiles of central individuals in recurrent cases highlight another layer. Adolescents undergoing strong emotional conflict sometimes experience dissociative episodes in which attention fragments and minor actions occur unconsciously. Throwing or knocking, performed without awareness, later appears external even to the actor. Such behavior, called automatism, is rare but documented in clinical settings. It aligns with Fodor's early hypothesis that poltergeist phenomena externalize repressed emotion energy, not in the physical sense, but as psychological discharge. Modern neuroscience supports the idea that stress can drive involuntary muscle responses, microtremors, or startle reflexes that interact with fragile surroundings to produce sound or motion. Environmental measurements add context. Many active locations exhibit fluctuating electromagnetic fields, drafts, or infrasound below human hearing. Frequencies between 18 and 20 Hz can induce vibrations in the eyes, generating shimmering shadows. Low-frequency resonance also affects the vestibular system, causing dizziness or dread. These sensations can trigger expectation and confirm the belief that something invisible moves in the room. Once belief forms, attentional focus amplifies subtle cues. An echo becomes a voice. A sway becomes a push. The loop between body and interpretation closes seamlessly. Sociologists studying documented cases find that activity often ceases when household stress resolves or key members leave. Conflict within families, suppressed communication, or the psychological strain of isolation precede many episodes. In this view, the poltergeist acts as metaphor made manifest, a physical mirror of emotional turbulence. When tension dissipates, so does the haunting. This pattern does not trivialize the experience. It shows how intimately mind, body, and environment interlock. Parapsychology, once hopeful of demonstrating genuine psychokinetic force, now leans toward multidisciplinary explanation. Controlled laboratory tests of object movement under observation have produced no replicable evidence beyond micro effects within statistical noise. Energy measurement equipment detects no anomaly exceeding ordinary mechanical or electromagnetic fluctuations. The human brain, despite its electrical activity, cannot emit enough power to move even a grain of dust across a table. The apparent energy of poltergeists, therefore, belongs to the psychological domain, attention, emotion, and collective belief acting through real physical channels of perception. Understanding how such experiences feel, however, remains essential. Witnesses often describe exhaustion, headaches, or emotional relief after an event, suggesting genuine physiological arousal. Measurements of heart rate and cortisol during staged investigations confirm elevated stress levels similar to those seen in trauma recall. The experience of witnessing movement without cause challenges the brain's predictive model of reality. Reconciliation demands cognitive effort. Once coherence returns through explanation or distance stress subsides. In this sense, investigating the unknown can itself be therapeutic, restoring a sense of control. Cultural studies show that societies interpret spontaneous disturbances according to prevailing worldviews. In some traditions, they are signs of ancestral displeasure, in others manifestations of witchcraft or psychic ability. The same sensory evidence, noise, motion, malfunction, acquires meaning through belief. Anthropologists emphasize that acknowledging these frameworks respectfully can help communities integrate extraordinary events without stigma. Scientific skepticism need not conflict with cultural empathy. Both seek understanding of human experience. Modern technology offers tools to separate perception from physics. Sensitive accelerometers, thermal cameras, and acoustic arrays now monitor suspected sites. When results are compared to participants' testimonies, discrepancies illuminate the cognitive component of haunting. Most impacts occur just beyond detection thresholds. Recorded sounds rarely match subjective reports. These studies reaffirm how memory reconstructs events in ways consistent with expectation rather than raw data. In darkness and stress, imagination completes the scene. From a neuroscientific standpoint, the brain's need for causal explanation drives much of what is labeled paranormal. An unexplained motion violates predictive coding, prompting immediate search for meaning. In the absence of a visible cause, the mind projects agency. This process, efficient for survival, creates the impression of intent behind randomness. Poltergeist phenomena demonstrate the same mechanism that makes us anthropomorphize wind or machines, a reflex to find minds behind movement. At a deeper level, these episodes reveal something about human creativity under pressure. When emotion, environment, and expectation align, reality seems to echo inner life. The raps and movements symbolize feelings that words cannot express. In this sense, the poltergeist belongs to psychology, more than physics, a narrative event woven by stress into matter. Understanding this does not diminish its mystery. It places the wonder within human nature itself. As research continues, scientists and historians approach the subject with balanced curiosity. Each case is a study not of ghosts, but of perception, memory, and the social mind. Whether caused by vibration, misinterpretation, or emotional projection, the phenomena invite the same lesson. Reality is a dialogue between the physical world and the stories we build upon it. And when the noise quiets and the house returns to stillness, what remains is awareness of the subtle forces that shape perception, the flicker of electricity, the tremor of stress, the imagination seeking order. From these restless rooms, the exploration moves outward again to subtler influences, the invisible fields and frequencies that surround us, and the question of how such environments might shape mood, perception, and belief. Invisible forces surround us constantly. Every heartbeat generates a faint electric field. Every household wire hums with alternating current. The planet itself radiates magnetic patterns that guide migratory birds and compass needles alike. Most of the time, we move through this web of energy without awareness. Yet under certain conditions, when frequency, intensity, and context align, some people report sensations they attribute to the unseen, dizziness, tingling, or an inexplicable sense of presence. For decades, scientists have explored whether electromagnetic fields can subtly influence the human nervous system and whether such effects might underlie experiences once labeled paranormal. Electromagnetic fields, or EMFs, exist on a vast spectrum. At one end are extremely low-frequency fields produced by power lines and household appliances. At the other, high-frequency radiation such as visible light and X-rays. The fields most relevant to perception lie in the lower range, from a few hertz to several hundred. These are weak enough to coexist with life, yet strong enough to interact with biological tissue. The brain itself operates through electrical activity oscillations between 1 and 100 hertz that coordinate neural firing. This overlap has led researchers to ask whether external fields might modulate internal rhythms. Experimental studies show that strong magnetic fields, such as those used in transcranial magnetic stimulation, TMS, can indeed influence perception and movement. A brief pulse applied to the visual cortex can create flashes of light called phosphenes. Stimulation of motor areas can cause small involuntary twitches. These effects, however, require field strengths thousands of times greater than those found in typical environments. Ordinary household or geological fields are too weak to depolarize neurons directly. Still, subtle interactions remain possible through secondary mechanisms, such as affecting calcium ion channels or altering the orientation of magnetically sensitive proteins. One of the most discussed hypotheses connecting EMFs to paranormal experience came from neuroscientist Michael Persinger in the 1990s. His God helmet experiments used complex magnetic patterns applied to the temporal lobes. Participants reported mild sensations of presence, floating, or emotional intensity. Persinger proposed that fluctuating magnetic fields could disrupt normal integration of sensory information, producing experiences similar to those reported during mystical or haunted encounters. Later replication attempts yielded mixed results. Some confirmed mild effects. Others found none when participants were blinded to the condition. Many researchers concluded that suggestion played a larger role than magnetism itself. Even so, the idea prompted broader exploration of how the environment shapes consciousness. Natural magnetic anomalies, such as those near fault lines or underground water flows, can generate variable fields detectable by sensitive instruments. Infrasound and vibrations, often accompany them. In certain haunted locations, investigators have recorded both EMF fluctuations and low-frequency sound. Whether these stimuli directly cause altered perception or merely contribute to atmosphere remains debated, but their presence underscores how physical context can influence emotion and attention. Physiology offers clues to why electromagnetic changes might feel unsettling. The vestibular system in the inner ear, responsible for balance and spatial orientation, is exquisitely sensitive to minute electrical potentials. Disturbances, whether from movement, vibration, or field interference, can create sensations of motion or pressure. Likewise, the pineal gland, which regulates circadian rhythms through melatonin production, contains magnetite crystals capable of responding to magnetic fields. Though the effect in humans is weak, animals use similar mechanisms for navigation. Fluctuations might slightly alter hormone release or sleep patterns, contributing to feelings of disorientation. Psychology amplifies these physiological cues. When people are told that a space has unusual energy or magnetic activity, they become more attentive to internal sensations. Minor dizziness or tingling, normally ignored, becomes meaningful. Controlled experiments show that expectation alone can double the number of reported physical sensations during EMF exposure, even when the field is off. This does not invalidate subjective experience. It illustrates how perception integrates external signals and internal belief into a single narrative. The body and imagination operate in partnership. From a health perspective, prolonged exposure to high-intensity electromagnetic fields can indeed affect biological systems, but the thresholds are well understood and regulated. Occupational safety standards limit exposure far below levels known to cause heating or nerve stimulation. Everyday sources such as mobile phones, Wi-Fi, and domestic wiring produce fields many orders of magnitude weaker. Comprehensive reviews by the World Health Organization and independent agencies have found no consistent evidence linking such fields to disease or psychological disturbance. Nevertheless, sensitivity varies. A small percentage of individuals identify as electrosensitive, reporting headaches, fatigue, or anxiety in the presence of electronic devices. Double-blind tests, however, reveal that symptoms correlate with awareness rather than field strength, indicating a psychosomatic pathway mediated by stress in the context of paranormal interpretation. Electromagnetic explanations occupy a middle ground between material and psychological models. They remind us that perception is both biological and environmental. A flickering light or buzzing device can subtly influence mood, and changes in geomagnetic activity may correlate with sleep quality or dream vividness. These correlations do not imply mystical energy. They show how finely tuned the human nervous system is to its surroundings. The brain is, in effect, an electromagnetic organ existing within a planetary field. Recent research extends this perspective to collective phenomena. Studies of geomagnetic storms periods when solar activity disturbs Earth's magnetic shield have found small but measurable shifts in human physiology. Heart rate variability and melatonin cycles show modest changes during intense solar events. Some researchers speculate that these fluctuations might influence population-level mood patterns, though causation remains uncertain. The results suggest that our biology, though insulated, is not completely isolated from cosmic conditions. Life evolved under these fields. Sensitivity may simply be a residue of adaptation. The emotional impact of invisible forces has long inspired art and belief. Before the electromagnetic spectrum was discovered, people described vital fluids, or ether, connecting mind and matter. Today, the vocabulary has changed, But the intuition persists, that something unseen moves through and between us. Science reframes this intuition without dismissing it, showing that invisible fields do exist, shaping technologies, weather, and possibly subtle aspects of mood. The difference lies in scale and interpretation. What once was spirit is now understood as physics still mysterious. But measurable dot, understanding the sensory dimension of EMFs, also informs architecture and urban design. Noise from power systems, inconsistent lighting frequencies, and flicker can cause discomfort or fatigue. Engineers now design environments to minimize these stressors, acknowledging that perception is not only visual but electrical. The same attention that once sought ghosts now improves well-being through careful control of light and energy. In this way, research born from curiosity about the paranormal contributes quietly to everyday comfort at its core. The study of electromagnetic influence reveals a principle echoed throughout neuroscience. The brain is an interpreter of fields, converting invisible patterns into experience. Vision translates photons into color. Hearing transforms vibration into tone. Balance reads gravity and acceleration. Electromagnetism is another layer in this symphony of unseen forces. When harmony holds, the world feels stable. When frequencies clash, perception wavers. The mystery is not that fields affect us, but that our minds so elegantly adapt to them as scientific understanding deepens. A gap between the natural and the extraordinary narrows. Many sensations once considered supernatural shocks, presences, tingling energies belong to this intersection of physics and psychology. Awareness of these mechanisms brings calm clarity. The unseen is part of the ordinary fabric of existence. And as our exploration moves beyond the physical environment, we return to the inner landscape, the mind's capacity to weave sensory fragments into coherent stories. The next step leads to memory and meaning, to how the brain transforms fleeting impressions into the narratives that define who we are. Human beings do not experience the world as raw data. Every sight, sound, and emotion arrives as fragments, which the brain weaves into a coherent whole. Memory provides the thread. Narrative provides the pattern. Together, they transform perception into identity. Without memory, life would be a series of disconnected moments. Without story, those memories would remain unshaped, a collection of impressions without direction. The need to find meaning in what happens is not a cultural habit, but a biological imperative, rooted in the way the brain organizes experience. Memory begins as a physiological process. When an event occurs, sensory information flows into the hippocampus and nearby structures in the medial temporal lobe. Neurons fire together in patterns representing sights, sounds, and emotions. Through chemical changes, modifications in synaptic strength, known as long-term potentiation, these patterns become stable traces. The process unfolds in layers: short-term encoding, consolidation during rest and sleep, and eventual storage across distributed cortical regions. Every recall is a reconstruction, not a replay. The act of remembering reactivates the network, reinforcing some connections and weakening others. Emotional significance determines which memories endure. The amygdala tags events with effective weight, influencing the hippocampus to prioritize certain details. Experiences that evoke fear, joy, or awe leave deeper imprints than neutral ones. This mechanism served survival. Remembering danger meant avoiding it later. But it also shaped culture, ensuring that stories filled with emotion, triumph, tragedy, mystery would be retold. Emotion and narrative are therefore entwined at the most basic neural level. Over time, memories merge into schemas, mental frameworks, that summarize repeated experience. Schemas allow quick understanding, but also distort detail. When new events occur, the brain fits them into existing templates, filling gaps with plausible elements. This predictive reconstruction explains why eyewitness testimony can be inconsistent, and why paranormal experiences often borrow imagery from cultural expectations. The mind prefers coherence over accuracy. A complete story feels truer than a fragmented fact. Autobiographical memory adds another dimension, the sense of self across time. The default mode network, active during daydreaming and introspection, links past experiences with imagined futures. It generates a continuous internal narrative. This is my life. Neuroscientist Antonio Damasio calls this the autobiographical self, a process that stitches moments into identity. When this network quiets, as in meditation or trance, the sense of individual continuity fades. Experience remains, but story pauses. The reemergence of narrative marks the return of ordinary consciousness. Psychologists studying meaning-making note that humans instinctively transform chaos into order through story. After trauma, people often recount events repeatedly, seeking a version that aligns emotion and logic. This narrative reconstruction helps integrate the experience into self-concept and reduces distress. Therapy, in many forms, uses this principle. By retelling life in new words, we reshape memory itself. Imaging studies confirm that reframing a painful memory activates prefrontal regions that modulate amygdala activity, reducing emotional intensity. Meaning calms the brain. Culture amplifies this individual process into collective memory. Myths, history, and religion encode shared interpretations of events. Anthropologists see storytelling as the earliest form of cognitive technology and external memory that stores lessons beyond one lifetime. Through story, societies preserve knowledge about danger, cooperation, and morality. Even scientific explanation follows this narrative impulse. A beginning, observation, middle, hypothesis, and resolution, discovery. The difference lies not in structure, but in method evidence replacing tradition as the measure of truth. The relationship between memory and belief is subtle. Once a story fits emotional expectation, it becomes resistant to correction. Cognitive dissonance theory shows that humans favor consistency between inner narrative and outer facts. When they diverge, we adjust perception to preserve coherence. This tendency explains why personal paranormal experiences feel unshakably real. They merge emotion, expectation, and recall into a unified episode. The memory itself becomes a conviction. Each retelling strengthens confidence, not necessarily accuracy. Neuroscience illustrates this through reconsolidation experiments. When a memory is reactivated, it temporarily enters a label state during which new information can alter it before being stored again. The line between remembering and imagining blurs. Over years, repeated reflection can transform a fleeting event into a polished narrative that carries personal truth even if factual detail shifts. This dynamic shows why myths evolve while maintaining emotional core. They are memories at the scale of culture. Meaning-making extends beyond explicit storytelling. The brain automatically seeks patterns linking events to purpose. This teleological bias, the assumption that things happen for a reason, emerges in childhood and persists into adulthood. It underlies both religion and science, the drive to answer why. When confronted with randomness, the mind generates causal links, reducing uncertainty. In this sense, the paranormal serves a similar function. It offers explanation when ordinary causes seem insufficient. The comfort of a coherent story outweighs the unease of ambiguity. Memory research also reveals the constructive nature of imagination. The same neural circuits activate when recalling the past and envisioning the future. This overlap allows humans to simulate possibilities, plan, and empathize. It also means that vivid imagination can feel as real as recollection. Studies using brain imaging show nearly identical activation patterns when participants remember a familiar place or imagine standing there anew. The difference lies in sensory precision, not in structure. This shared circuitry explains why dreams, déjà vu, and recollections blend seamlessly in consciousness. At the philosophical level, narrative grants continuity to a universe of change. The physical world unfolds through cause and effect, but meaning requires sequence and perspective. The human brain, facing entropy and uncertainty, builds order through time-bound stories. These narratives do not float above biology. They are the biological function of order-making itself. Memory ensures survival by prediction. Story ensures survival by purpose. The two are inseparable. In the calm view of science, this understanding carries both humility and beauty. What people once called destiny or fate may be the brain's way of linking events into significance. The same mechanisms that produce myths also produce empathy and creativity. Recognizing them does not strip life of mystery. It reveals that the capacity for meaning is itself a natural wonder. Modern cognitive science continues to explore how narrative shapes attention, emotion, and collective behavior. Artificial intelligence models now simulate memory networks, showing how patterns emerge from iterative reconstruction. These studies echo the ancient insight that reality, for conscious beings, is always partly remembered and partly imagined. Facts provide structure. Meaning gives direction. As we reflect on this, another question arises. If memory and story create belief, how does knowledge differ? What separates conviction from evidence, interpretation from understanding? The next chapter turns to that boundary, the psychology of belief itself, where science meets faith and where the search for truth becomes a study of why we believe at all. Every human mind carries a quiet tension between curiosity and certainty. We seek patterns, explanations, and meaning, yet we also long for stability in what we already know. Belief bridges that gap. It allows us to act confidently in an uncertain world. From superstition to science, every system of thought begins with the same impulse, the need to understand and to belong. The study of belief, therefore, is not a challenge to faith. It is an inquiry into how the brain constructs reality itself. Belief begins in perception. When the brain receives sensory data, it immediately interprets it through prior experience. This predictive process filters noise, fills gaps, and produces a coherent picture. Cognitive neuroscience calls it predictive coding. The mind does not record the world. It forecasts it. Each new observation tests an internal model. When predictions succeed, the model strengthens. When they fail, the brain updates its expectations. Beliefs are these models' neural blueprints for anticipating the future. Because prediction ensures survival, the system favors stability over accuracy. Once a belief forms, it resists change unless error signals become overwhelming. This inertia explains why contradictory evidence rarely convinces immediately. The brain interprets anomalies as noise before reconsidering the framework. Psychologists call this confirmation bias. We attend to information that supports our assumptions and discount what does not. It is a universal feature of cognition, not a flaw of character. Understanding it brings compassion to debate. It reminds us that minds defend coherence before they seek truth. Emotion intensifies this dynamic. The limbic system anchors belief in feeling. When an idea aligns with emotional need, offering safety, identity, or purpose, it becomes more than a hypothesis. It becomes part of the self. Functional MRI studies show that challenges to deeply held beliefs activate the same neural circuits as threats to physical safety. Reason alone rarely dismantles such structures because reason operates within them. To modify belief, the brain must experience new emotional context, not just new information. Cultural evolution built entire frameworks upon this biological foundation. Shared beliefs bind groups through trust and coordination. Sociologists describe them as social glue, narratives that align behavior without constant negotiation. Whether expressed as religion, ideology, or science, these systems provide predictive maps for collective life. Each contains norms for evidence and error correction. Science distinguishes itself by institutionalizing doubt, but even it depends on belief in reason, method, and consistency. The difference lies in how correction is invited rather than resisted. The psychology of belief extends to the paranormal. Surveys show that belief in ghosts, astrology, or psychic phenomena correlates not with ignorance, but with intuitive thinking style. Cognitive scientists differentiate between System 1, fast and automatic, and System 2, slow and analytical. Intuitive thinkers rely more on pattern recognition and emotional salience, making them susceptible to seeing meaning in randomness. Analytical thinkers pause to test hypotheses, but both systems coexist in every person. The balance shifts with context. Fatigue, stress, or awe can temporarily tilt the mind toward intuition. Paranormal interpretations often emerge in those moments when emotion overwhelms analysis. Evolutionary psychology offers further perspective. Early humans who assumed agency behind rustling grass, whether predator or wind, were more likely to survive. The cost of false positives was low. The cost of false negatives could be death. This hyperactive agency detection remains with us, leading modern minds to sense intention in coincidence or design in chaos. The same tendency that fosters art and religion also fuels belief in unseen forces. It is not irrational, but deeply adaptive, a side effect of vigilance shaped by survival. Neuroscience identifies specific regions involved in belief formation. The ventromedial prefrontal cortex integrates evidence with emotional value. The posterior cingulate cortex links beliefs to personal identity. The temporal parietal junction processes attribution of agency. Together, they construct meaning from experience. Damage or stimulation in these areas can alter conviction. For example, patients with lesions in the prefrontal cortex may accept improbable statements more readily, while hyperactivity in the temporal lobe can increase feelings of presence or revelation. Such findings reveal that belief is not abstract, it is physiological, embedded in the tissue of the brain. Belief also interacts with memory. Once an interpretation forms, subsequent recollections align with it. Experiments on memory conformity show that groups recalling ambiguous events gradually converge on a shared version, even if it differs from fact. Repetition cements the collective belief through familiarity, what psychologists call the illusory truth effect. A statement heard often enough feels true, regardless of evidence. In digital culture, this mechanism operates on a planetary scale, shaping opinions through repetition rather than accuracy. Awareness of it helps restore discernment. At the boundary between belief and knowledge lies verification. Knowledge requires not just conviction, but correspondence with reality, tested through observation. A scientific method formalizes this process: hypothesis, prediction, experiment, revision. Each cycle reduces uncertainty, though never to zero. Knowledge remains provisional, but its strength grows with replication and coherence. In this sense, science is structured humility, a disciplined willingness to update belief. Its power lies not in certainty, but in its capacity for change. The emotional comfort of belief and the intellectual rigor of knowledge need not oppose each other. Many scientists describe awe, not detachment, as the motivation behind inquiry. The sense of wonder once ascribed to mystery now deepens through understanding. Knowing the mechanism does not remove beauty. It reveals its structure. The night sky remains vast, whether one sees constellations or galaxies. The difference is that knowledge expands rather than confines imagination. Social neuroscience adds another layer. Belief is contagious because minds mirror one another. When we hear conviction in a trusted voice, our mirror systems and reward circuits synchronize, reinforcing alignment. This process fosters cooperation, but can also entrench misinformation. Cultivating skepticism, then, is not rejection of others, but care for shared reality. It is the gentle discipline of testing stories before building identity upon them. Philosophically, belief represents the bridge between experience and meaning, while knowledge refines the bridge through verification. Both emerge from the same cognitive machinery. Without belief, motivation withers. Without testing, belief stagnates. Humanity advances when curiosity outpaces certainty, when the unknown invites exploration instead of fear. From this vantage, the study of belief unites the themes of perception, emotion, and culture explored throughout the series. Paranormal ideas, scientific theories, and personal convictions all stem from the same drive: to reduce uncertainty in a complex world. Understanding that drive dissolves the border between the rational and the mystical. Each is an expression of the same searching mind. In the calm rhythm of reflection, it becomes clear that belief is not an error to be erased, but a stage in the growth of knowledge. The mind must first imagine before it can measure. Myths, experiments, and discoveries all begin as possibilities glimpsed in the dark. What matters is the transition, the willingness to test, revise, and expand. In that movement from wonder to understanding, human consciousness fulfills its defining trait, curiosity, illuminated by awareness. And so the exploration returns to its origin. The mysteries once called paranormal reveal themselves as facets of perception, memory, emotion, and belief. The unknown remains vast, but not empty. It is the space where science and imagination meet, the gentle frontier where the search for truth begins anew. Throughout history, what we called paranormal has often marked the boundary of understanding, the region where questions outran evidence. Lightning became electricity, alchemy became chemistry, astrology seeded astronomy. Each step transformed mystery into knowledge without erasing wonder. Today that frontier moves again, not through seances or superstition, but through algorithms, sensors, and artificial intelligence. Machines now explore dimensions of data once invisible to human senses, revealing patterns that redefine what it means to perceive. Artificial intelligence extends human observation beyond the limits of attention. Modern sensors monitor the planet's magnetic field, atmospheric particles, and neural activity with precision unimaginable a century ago. AI systems analyze these vast streams of information, detecting correlations too subtle for intuition. In this sense, they act as new instruments of perception tools that translate complexity into clarity. Yet the more they reveal, the more they challenge the distinction between natural and supernatural. Where earlier generations saw spirits in the unknown, we now see signals, frequencies, and probabilities. The mystery persists, only the vocabulary changes. Consider how algorithms already reinterpret human experience. Brain-computer interfaces decode simple intentions from neural activity. Emotion recognition systems map facial micro-movements invisible to the naked eye. Machine learning models predict behavior from digital traces. These technologies expose how much of thought and feeling can be quantified. They also raise new philosophical questions. If an AI can infer emotion from data, does it understand empathy, or does it merely mirror patterns? The same question once asked of mediums and mystics now applies to machines. Where does interpretation end and consciousness begin? In neuroscience, AI accelerates exploration of phenomena once labeled paranormal. Machine learning models trained on EEG and fMRI data detect precursors of awareness and even reconstruct rough images from visual cortex activity. Experiments with predictive coding networks simulate hallucination-like perception, showing how the brain might mistake imagination for reality. These findings demystify experiences such as apparitions or voices by modeling them computationally. The supernatural becomes a simulation of natural processes under extreme conditions. What once demanded belief now invites measurement. AI also revisits the study of coincidence. Large-scale data analysis reveals how patterns that seem extraordinary can emerge naturally from probability. Social networks, for example, produce synchronized events, shared dreams, simultaneous thoughts, parallel discoveries, simply because billions of people act within overlapping environments. Algorithms quantifying randomness show that what feels impossible often reflects the law of large numbers. Yet understanding this does not diminish the sense of wonder. It reframes it. The improbable becomes another name for the complexity of reality. In psychology, digital tools map belief formation with unprecedented depth. Natural language models analyze how stories spread through culture, how rumor becomes conviction, and how emotional tone predicts viral transmission. These insights help explain why certain paranormal ideas endure. They satisfy cognitive templates for agency, morality, and awe. AI does not disprove these narratives. It traces their evolution. By studying millions of texts, it reveals how humanity collectively negotiates meaning. In doing so, it turns folklore into data and data back into reflection. Beyond analysis, technology also generates new kinds of experience. Virtual and augmented reality recreate sensations once confined to mystical imagination, out-of-body movement, presence, or time distortion through controlled sensory manipulation. Users report feelings nearly identical to those in spontaneous paranormal events. This convergence suggests that consciousness can interpret any sufficiently immersive stimulus as reality. The line between internal and external, vision and simulation, grows thinner each year. As technology expands perception, it also expands the range of what can feel otherworldly. At the intersection of AI and quantum physics, researchers explore the limits of measurement itself. Quantum sensors now detect fields weaker than biological thresholds. Entanglement experiments probe correlations once thought impossible. Some enthusiasts speculate that these frontiers may reveal new layers of reality, where information behaves in non-classical ways. While mainstream science remains cautious, such exploration continues a long tradition. Each generation pushes the boundary of what counts as natural. Whether or not such discoveries occur, the process embodies the same human impulse that once searched for spirits in the dark, the desire To understand connection beyond visibility, ethical questions accompany these advances. As machines interpret human emotion and thought, privacy acquires new meaning. Reading neural signals or emotional cues borders on a technological form of telepathy. Regulation must balance innovation with respect for mental autonomy. The future challenge is not whether AI can mimic the paranormal, but whether it can respect the intimacy of consciousness. In exploring the unseen, science must remember the sanctity of the inner world. Artificial intelligence also changes how knowledge itself evolves. Traditional science proceeds through hypothesis and experiment. AI discovers patterns first, then seeks explanation. This reversal mirrors ancient mysticism, which began with revelation and pursued understanding afterward. In a sense, machine learning brings the cycle full circle, combining intuition and analysis, pattern and proof. The collaboration between human curiosity and algorithmic perception forms a new mode of inquiry, one that may blur the boundary between empirical and experiential knowing. Culturally, these developments may redefine what people mean by paranormal. Instead of ghosts or telepathy, the mysteries of the 21st century concern consciousness, simulation, and artificial minds. Philosophers debate whether a sufficiently advanced AI could have subjective experience, whether awareness might arise spontaneously from complexity. If it could, then the frontier once occupied by spirits and gods would become a frontier of emergent intelligence. Humanity would again face a presence both familiar and incomprehensible, created in our image, yet beyond our understanding. In this calm light, the paranormal becomes not a separate realm, but a mirror of evolving perception. What once appeared beyond nature gradually folds back into it through explanation, leaving new edges to explore. AI does not end mystery. It multiplies it. By expanding the scale of observation, it exposes deeper questions about mind, meaning, and reality. The future of the paranormal, then, is the future of consciousness itself, a continuing dialogue between what we know, what we feel, and what we are still learning to perceive. As we move toward that horizon, the journey remains the same, from wonder to inquiry, from perception to understanding. The tools change, microscopes become algorithms, oracles become data, but the motive endures. Curiosity is the quiet engine of progress, the same impulse that looked at a moving shadow and asked why. The search for the unseen continues, not to prove the supernatural, but to deepen our understanding of the natural world and of ourselves within it. And as this exploration draws to a close, what remains is a gentle realization. Every mystery, once examined with patience and clarity, becomes part of the continuum of knowledge. The unknown is not the opposite of understanding. It is its beginning. At the end of every investigation, after instruments fall silent and equations close their loops, there remains a quiet space where curiosity itself becomes the subject of study. This is the calm frontier, the meeting point between knowledge and mystery. Here, the questions that began with ghosts and visions transform into reflections on perception, belief, and the limits of human understanding. The frontier does not vanish as science advances. It simply moves forward, carried by the same need to ask why. Across history, progress has not extinguished wonder, but refined it. Lightning once symbolized divine anger. Today, we know it as the discharge of atmospheric electricity, yet the sight of it still inspires awe. The night sky that ancient people filled with deities is now mapped by telescopes, but the vastness it reveals is no less humbling. Each explanation deepens rather than diminishes mystery, revealing layers within layers. The more precisely we describe nature, the more intricate its beauty becomes. Science and wonder, far from opposites, are twin expressions of the same impulse to see clearly. The psychology of wonder begins in surprise, the recognition that the world exceeds our expectations. Neurologically, this moment activates reward circuits and attentional networks, flooding the brain with dopamine and norepinephrine. Attention sharpens. Time seems to slow. Researchers call this state awe, a blend of vastness and curiosity that encourage learning and connection. It is one of the rare emotions that simultaneously humbles and expands the self. In this sense, awe is the emotional bridge between the paranormal and the scientific. It is how the mind reacts to the unknown, whether it attributes it to spirit or to law. Cognitive science suggests that wonder plays a vital role in creativity. When the brain encounters information that does not fit existing models, it enters a state of heightened plasticity. Networks that normally operate separately, analytical, emotional, and associative, begin to synchronize. This integration fosters insight. Many scientific breakthroughs originate in such moments of dissonant curiosity, when observation defies prediction. Einstein called it holy curiosity, a phrase that captures how discovery can feel reverent without being supernatural. The capacity for wonder, then, is not a byproduct of ignorance, but a condition for progress. Culturally, humanity has always balanced two ways of knowing, the mythic and the empirical. The mythic mode personifies nature, turning lightning into gods or fate into story. The empirical mode measures, tests, and predicts. Rather than replacing one another, they coexist as complementary languages. Myth offers emotional truth. Science offers structural truth. Together, they mirror the dual architecture of the brain-right hemisphere integrating pattern and metaphor, left analyzing sequence and detail. The harmony between them produces understanding that is both accurate and meaningful. The calm frontier acknowledges this balance. It recognizes that knowledge alone cannot satisfy the human need for belonging, and that faith without evidence cannot guide technology or medicine. In this space, dialogue replaces opposition. Physicists converse with philosophers, neuroscientists with artists, and both learn that perception and meaning arise from the same biological canvas. This cross-disciplinary approach reflects the modern realization that reality cannot be grasped through a single lens. Complexity demands collaboration. Within neuroscience, even the study of consciousness now carries echoes of earlier metaphysics. Researchers investigating the neural correlates of awareness confront questions once reserved for mystics. What is the nature of subjective experience? How does matter generate mind? The tools are empirical, yet the questions remain existential. Some propose that consciousness emerges from information processing, others that it is fundamental to the universe. Neither stance cancels the other. Both reflect attempts to articulate what cannot yet be measured completely. The mystery of mind, once the domain of spirit, now stands at the cutting edge of science. Technology magnifies this dialogue. Artificial intelligence and neuroscience together reveal that understanding perception is inseparable from understanding selfhood. As machines learn to recognize patterns in data, they mimic fragments of cognition, but not consciousness. Their progress forces us to define what awareness truly means. Is it the capacity to compute, to feel, to reflect? In asking these questions, humanity revisits its oldest philosophical concerns through digital mirrors. The unknown we once located in the heavens now resides in the circuits of our own creation. Ecology offers another dimension of the calm frontier. The planet itself, viewed from space, evokes the same sense of fragile unity once reserved for spiritual revelation. Environmental science reveals that human survival depends on maintaining equilibrium with systems far larger than ourselves: oceans, forests, atmosphere. The realization that every breath connects to photosynthesis thousands of kilometers away restores a kind of scientific spirituality, interdependence as sacred fact. The unseen networks of climate and biology form a modern counterpart to the ancient idea of a living Earth. Sociologically, the evolution of belief reflects the mind's adaptability. As supernatural explanations yield to natural ones, the need for meaning persists, shifting form but not intensity. The modern fascination with consciousness, energy, and interconnectedness echoes ancient intuitions under new names. Science fulfills its deepest purpose when it translates wonder into understanding without erasing reverence. The calm frontier is precisely this translation: respectful dialogue between awe and analysis. From a philosophical standpoint, humility is its defining tone. Science recognizes its own boundaries. The unknown is not failure, but horizon. Every discovery opens new questions. The human condition lies not in possessing answers, but in living within the unfolding. Awareness of this continual movement softens certainty and cultivates curiosity. In a quiet way, such humility becomes a form of wisdom, the understanding that truth is not a destination, but a relationship with reality. As we look ahead, the convergence of disciplines hints at a new synthesis, a worldview that honors both measurement and meaning. Physics explores the origins of time. Biology traces consciousness through evolution. Psychology maps the narrative mind, and philosophy interprets their implications. Each field adds a thread to a single tapestry, the story of awareness becoming self-aware. The paranormal, once an outpost of speculation, becomes a metaphor for this ongoing expansion of perception. The unknown no longer frightens. It invites participation. In this perspective, wonder is not a residue of ignorance, but the atmosphere of discovery. It is the stillness before comprehension, the pause that precedes insight. When science reaches its temporary limits, wonder keeps it moving. It is the calm pulse beneath curiosity, the reminder that to ask is itself an act of connection. The frontier remains, not as a border to cross, but as a horizon that recedes with every step of understanding. And so the exploration ends, where it began, with the simple awareness that reality, seen clearly and patiently, is already extraordinary. The paranormal dissolves into the normal, and the normal, examined deeply enough, reveals its own quiet miracle. Between knowledge and mystery, there is no wall, only a rhythm of discovery. Like breath, the universe inhaled as question, exhaled as understanding. Thank you for sharing this calm time with Calm Science Sleep. May the questions linger softly, like distant echoes fading into rest. If this peaceful science kept you company tonight, a like or a quiet subscription helps our journey continue. Join us again for another silent exploration, where knowledge breathes slowly and wonder never ends.